Miami, DC, prefer Versace. All Philly hoes know it's Mosquito. Every cutie with the booty for the coochie. Now who's the real dookie? Meaning who's really the shit? The leaders fried dicks. Frank White push the stick on the Lexus LX. 4.5. Bulletproof glass tips if I want some ass. Gon' blast sweet slugs, ass questions black. That's how most of these so-called gangsters act. At last, a nigga rapping about guns and rods, tits and bras, menage a trois, sex and expensive cars. Still on the table, condo paid for, no car payment. At my arraignment, no court cleaner. Your daughter's tied up in the Brooklyn basement. Basic, not guilty. That's how I stay true. Get richer than rich, so you niggas come and get me.
Hey folks, I just a reminder that we're actually in the pre-show. We'll officially be kicking things off at the top of the hour. Please join the conversation. Join us on Slack at slack.weave.works and join us at hashtag GitOps Days. Thank y'all.
It's been a long way down. It's been a long way back. It's been a long way down.
Nothing will keep us together. We can be there.
Oh, Daniel, you can keep the music going. We're actually going to dance here for a little bit longer.
Oh, we can be heroes. Just one day. And that is we can be heroes. And that is and that is and that is and that is
Have you ever felt like you've been hurt before? By the ones that said they only loved you more? Inflicted pain and scars of sorrow, like an empty shell I wait for tomorrow. I said you're wondering why you walked away. Did I ever do you wrong in any way? Was it something I said to you that made you change? There is no more sun, there's only cloudy days. Yeah. What goes around will come around and come back and get ya.
All right, all right. Thank you so much. Hey, Pinky, how's it going?
Hey, Tamao, how exciting.
It's so exciting to see all these people logged in. This time we're trying a little bit different. People know have joined our GitOps days in the past. We've done them on YouTube. This time we thought, let's just consolidate straight on Zoom. So welcome to the GitOps one-stop shop event. Hopefully you are here for that and you're not here for a party. You're like, wait, where'd the awesome music go? have to listen to Tech Talks? What? So my name is Tamao Nakahara. I run the developer experience team at Weaveworks, and I am so excited to have my trusted co-host, Pinky. You want to introduce yourself?
Yeah, I'm Priyanka Ravi. I'm a software developer, consumer of Flux. Very excited to be here.
So thank you. So we have a wonderful, good chunk of hours. We actually were planning for maybe 2.5, and then more and more people were like, hey, can we speak? And we said, you have amazing Flux solutions. So we are so excited to have such an incredible lineup of speakers. I'm excited to have an amazing host, and it's so great to see everybody joining on Zoom today. So quick housekeeping, you will see this in the Zoom chat all day today, that we want to bring the chat to Slack. So our trusted community managers / developer advocates will be pasting those in the chat there. So we want to make sure that, a lot of conversations will continue well after the event. And that's why we want to make sure that we can have people starting those conversations on Slack. So it's so fun to be like scrolling through here, all the countries represented. We have Brazil. I'm from Oakland. We've got Nigeria. We've got Brittany. We've got many more just all coming in. So it's very exciting to see everybody joining from many places. So this is our quick little intro. In about 5 minutes, we'll have our first speaker. So wanted to take a little time here to explain the goal of this event for you. So hopefully many of you are here because you want to get started with GitOps. And so that, whoop, I'm seeing Scott here in our background. Hi, Scott, how are you doing? We can see your screen. And so many of you might be getting started with GitOps today. And those of us and some of our speakers here, maybe, and Pinky, maybe are some people who've been practitioners for a while. And we see a vision where at some point, when you say, I want GitOps, it might literally be that you are using one of the cloud vendors, maybe one of the ones presenting today, and you literally see a button that says GitOps, and you click that button. And some of the demos today you'll see are pretty close to that vision, which I think is fantastic, because you're trusting your vendors, you're trusting the platforms you're using to provide you with the best technology possible to get the best GitOps experience. And for this particular event, we really wanted to celebrate the fact that all of the vendors speaking today are using Flux to provide that GitOps solution. So we thought, what a wonderful celebration we'd love to have. And what a way to have one of our Flux users, Pinky, here joining us to MC. We have just a minute or so, but Pinky, what is like one of the top things for you that as you've been using Flux that you say, it's great that we use GitOps today?
My team loves that basically Flux has enabled us to streamline the whole process to go to production, and it's so easy to use for consumers. We don't have to explain too much, and basically it also enables us to like not have that configuration drift. We love using Flux.
Excellent. So to show the structure before we go into, there's basically 30-minute vendor showcases throughout the latter half of the event. Right now, we have a couple of short talks that will sort of set the stage. So again, like I said, we've got Pinky here, who's a great existing user of Flux. We'll be kicking off first with Ihor Dvoretsky, who is a developer advocate for the CNCF. Why do we mention that? Because, well, Flux is open source, and Flux is in the CNCF. We are an incubating project, and we are this close to graduation. So hopefully we'll be joining with Pinky again when we do our big fat Flux graduation celebration. We're really, really excited. Got through the security audit steps. We're going through some of the reviews for that, and it looks like super, super good. So we're very excited about that. Had a wonderful time at KubeCon. We had a Flux booth where I got to see Pinky in person.
Yes, I know.
It was so fun. So hopefully some of you joined us for that. We had like an ambitious in-person at KubeCon in Los Angeles and an online version of the Flux booth, and I took a lot of screenshots. I was actually there in person for the first 2 days and then back at home online for the last 2 days. So it was really cool to see both sides of this Flux booth in action. We had many Flux users coming to speak about their experience. We had many people joining to hear them, both at the booth and online. It was really, really fun and really great to hang out with, as I mentioned, I work at Weaveworks, hanging out with our wonderful developer experience team, as well as our Flux engineers, maintainers, and as you'll hear shortly as well, Michael Bridgen, who is the creator of Flux. So we have such a fantastic couple hours here for you. Again, check the chat. If you're in the Zoom, Scott will be actively sharing the link to the Slack channel so that you can chat over there. You know, I'll be multitasking and hoping to chat with many of you as well. We'd love to hear, you know, why you're here, why you're thinking that GitOps might help give you great benefits, maybe solve some, give some solutions to pain points, all those types of things. And here and there, Pinky and I will be dancing to music at DJ Desired State, aka Daniel Holbach, our community manager for Flux, who's also clearly multi-talented and able to bring fantastic music to us. So I hope everybody was enjoying it as much as we were. If you can't hear it, let us know as well. I was definitely sipping my coffee, tweeting out a happy tweet, like, oh, this is like the perfect groove for here, Oakland. I'm in Oakland. It's 9:10. So thanks, Pinky. With that, I've taken on the challenge of pronouncing Ihor's name. So I will take the intro to Ihor. So we are very excited. Ihor, thank you for joining us.
Sure, it's a big pleasure.
Yes, thank you. I think it's evening for you. Where are you hailing from again?
Right now, I'm in Ukraine. I've actually landed from the United States like around 6 hours ago. So on my way back from KubeCon. So
all right, so you're
really challenging. I still cannot really clearly get which time zone I'm in, but my watch tells me that it's 7 p.m. right now.
Yes. Okay. So great. So hopefully you're enjoying some evening beats. So quick intro, Ihor Dvoretsky, who probably many of you know, of course, the CNCF, which is the Cloud Native Computing Foundation. Ihor is a dev advocate there. And thank you for joining us to celebrate this major milestone for a CNCF project, which is Flux. So please take it away.
Perfect. Thank you, Tamao. Yeah, it's a really big pleasure for me to be here. And as I mentioned before, I just made it from KubeCon, like significantly big event that we had last week in LA. Significantly big in terms of like the kind of like the pandemic times when we had like 3,500 people on site and more than 20,000 people online. And I believe that there have been so many people who've been interested in GitOps and Flux project specifically. And as you mentioned before, like there've been the Flux virtual and a physical booth there. And like, I haven't attended actually the virtual one because I've been on site, but I've noticed that been like all the time, there have been some folks who've been showing up to the on-site booth, who've been chatting with the Flux maintainers. And this definitely recognizes the kind of like the popularity of the project these days. I'm slideless today, no slides. Just want to highlight about like how the Flux project is important for the cloud native ecosystem and is notable. And it's worth mentioning that Flux is in the incubation stage. So CNCF has accepted Flux as a sandbox project a couple of years ago, back in 2019. It was like pretty young and emerging project. That was kind of like the development, like the further development and the further enhancement of the GitOps concept that was established a couple of years ago before that. So Flux is basically the project that is the realization of the GitOps concept. But a couple of years after that, at the beginning of the current year of 2021, CNCF has accepted, the CNCF TOC, the Technical Oversight Committee, has accepted Flux into the incubation stage, which means that this project is no longer recognized as something like brand new. Nobody knows about it. The project that could have like kind of like the small user base and the code base and so on. So basically the accepting into incubation means that this project is well recognized by the end user community and it's well recognized by the developers community. And like, honestly, I'm personally pretty excited about this. And probably this is the best time to shout out to all the Flux maintainers, including Daniel, Scott, Stefan, Allison, and many, many others, together with the community managers of this amazing project. So you are building this community together. And what is more important is that this project is not being built by the single company. It's not being developed by the single company. Obviously, this was a project that has been born and has been developed by Weaveworks primarily at some point of time. But today we have a couple more vendors and a couple more commercial companies that are building projects and are offering services on top of this project, and then way more maintainers also from the different companies and independent maintainers who are making the contributor base of this project way more diverse and way more inclusive. And this is definitely important for the open source project, because you cannot build the successful open source project, you cannot build a successful open source community by just building it inside a, let's say, the single company. So this diverse community from the various maintainers from the different areas is definitely important. Another extremely important thing that I want to highlight about the Flux success and about Flux growth and Flux development is the number of the end users and adoption by the end users. And as you know, as most of you may know, the CNCF, at CNCF, we have the end user community, and the end user community is on a kind of like the regular basis releasing the so-called CNCF Tech Radar, where we're focusing on some specific area of the technologies, and the end users, the CNCF end users, are basically defining and letting us know about like which project they are using on a regular basis and like in which stage. So basically they can mention that they're like just adopting and trying to use some of the GitOps projects, or some of them are like used definitely intensively in the production environments. And when we released the CD, the CI/CD, and the GitOps Tech Radar, it's worth mentioning that Flux was one of two projects, together with Helm, that have been recognized by the CNCF end users at that adoption stage that could be recognized as the most level of adoption. In other words, there is a big number of the CNCF end user member companies that are using this project in production. And from a personal standpoint, this is the great success. Another thing that I want to mention is like Flux is growing significantly these days. And yes, Tamao mentioned probably in some future we'll see Flux as being graduated. So at least with the current pace of development, with the current pace of growth of the community, and with the current pace of community involvement into the project, we can definitely see this project in the list of the graduated project, which can be recognized as the highest level of maturity, the highest level of the community adoption, and the highest level of the end user adoption. So I hope that all of you, we have more than 150 people right here at this event. So I hope that all of you will enjoy this event. Wishing my best kudos to all the Flux maintainers and all the Flux contributors and all people who are building this Flux ecosystem. So I hope you'll have the great event today. And back to you, Tamao, now.
Hey, thank you so much, Ihor. That was great. Those updates are so awesome. Thank you. Next up, we're actually going to have Michael Bridgen, which is really exciting because he's the creator of Flux. And he's a principal engineer at Weaveworks, and he's going to basically chat with Tamao, and they're gonna tell us about Flux. So it's really exciting to hear that it's almost graduated. That's so exciting.
Yes, excellent. And we're actually about a minute and 10 minutes, 10 seconds early. So if this is a chance, I was in the middle of answering someone's question in our Slack channel. If anybody else has questions regarding Flux and our graduation, let us know. Otherwise, let me just see here. Oh, look, I see some people answering. So with that, okay, we will transfer over. We'll be slightly 30 seconds early. Michael, how are you doing?
I'm okay, thank you. How are you?
Excellent. Michael is hailing from, are you in London or are you outside of London these days?
I'm in London. Yeah.
Excellent. I remember the days and look back fondly to the days that we can hang out again in London. So it'd be great.
Yeah,
so
absolutely.
As Pinky just introduced, maybe some of you don't know that Michael is the creator of Flux. Early in the days, it was a project that was created here at Weaveworks. And so it's been really great to see this journey, and hopefully you enjoyed Ihor's talk right now about how important it was for us to make sure that, one, it was open source, and that we had it outside in a foundation, the CNCF. So it's my pleasure here to have a quick chat with Michael to kind of reflect on this journey and how, you know, those thoughts might be useful for people who are getting started with GitOps today. Because I think some of Michael and the team's experience from the time, I don't want to say that they were at the forefront, but they kind of were. They were having the same kinds of thoughts and sometimes emotions about GitOps that maybe some of you had today. So we hope to share that and hopefully be useful. So first of all, Michael, as having created Flux, I'd like to just sort of think back, put your cap on from that time. I'm sure you weren't thinking about something that you'd put open source and you'd put into a foundation. You probably had very concrete, pragmatic problems that you needed to solve. Can you share some of that with us?
Yeah, of course. So you're right. We the whole open source thing came afterwards. The basic need we had at the time was that we had a software as a service platform called Weave Cloud, still around, and we needed to be able to roll out new code. That was pretty much it. That was the requirement. And so we built this thing. Actually, the first thing that was called Flux was this very elaborate system where it kind of did canary rollouts and then showed you charts of error rates and comparisons and stuff like that, which and had like a client-side proxy for redirecting traffic to each service and so on. And this was all before people were talking about service meshes and all that stuff. And it was way over-ambitious. So that sort of didn't go anywhere. Then we just went back to the original requirement, did something a lot simpler. And that was pretty successful. It did what we needed it to. And what it was doing, because we kept all our config in Git, it would roll out a new container image, and then it would make a commit to Git to make sure that Git had kind of the right recovery point if we needed to use config from Git. And then one day, someone said, why don't we just apply everything from Git? And this was like the unthinkable thought. And we did it, and it was a bit frightening, but it did work.
That's exciting. So we were chatting about how there might be a lot of people today who have those same emotions, right?
Yeah,
and
yeah.
What was the mindset where you said, okay, this seems scary, but we'll try it anyway? What were the things that maybe you had in place? Or if you're just like, okay, we're gonna do it.
No, that's what we did. We shut our eyes and flipped the switch and crossed the things. We were pretty lucky, actually, because we had some people that were quite experienced, SREs, site reliability engineers. I think that's a sort of term of art, but they had put in place a lot of kind of a very good safety net. So we had a support rotor and runbooks, and basically lots of very detailed instructions for recovering the system if anything went wrong. So it was sort of frightening to flip the switch, but we knew that ultimately nothing was going to be too terrible. And having GitOps or having Flux, once we'd flipped that switch, it smoothed away a lot of mistakes that might be made by people doing things by hand. But we always needed that safety net. You know, you can't do without it really. It's complementary.
Yeah, and I guess a shout out also to Google, right? I guess Google has really made that a practice of having the SREs.
That's right.
And I guess a quick question, like, so you had some people on the team with that experience. What was the length of time to sort of train up on like, hey, this is the way we're going to think about this? And then probably at the time wasn't even thinking about, I mean, the term GitOps didn't exist, but it clearly helped with creating the right like work environment, the team environment. So what was the on-ramping for that? Like a couple weeks, a couple months, different mindset?
So people that were, so in terms of GitOps, I mean, we were already keeping everything in Git, you know, so we had kind of layers we had used Terraform and Ansible, and then we had Flux for keeping runtime config. So we're already doing a lot of the things that you would think of as GitOps, or you know, ended up being referred to as GitOps. And the thing that was missing was automation, or some of that kind of last mile delivery stuff. But in terms of bringing people on board, yeah, I think we even went as far as having a kind of training program. And this was quite a small company, remember? So this was a bit unusual, perhaps. We had a training program, and then we would shadow people. So I think that's important because, you know, you have the safety net of all the sort of operations stuff you've set up, but you also need a safety net for individuals because it's pretty scary going onto the support rota, even when there's lots of automation. And you don't want to press the wrong button. So it's quite important to help people through that initial rather frightening period.
Yeah, definitely. And, you know, hopefully that helps people understand if you're getting started. We totally get it. If, you know, trying new things, wondering if your team is right for it. All those things are very valid concerns. And it's great to have an event like this where hopefully either you meet other community members who can share that information, or you use some of these platforms where that safety is built in. And speaking
it turned out that flipping that switch was a total non-event. It just made almost no difference to anyone's life, yes. Except for there was some, you know, fewer opportunities to make mistakes. But,
yes.
Yeah, nothing went wrong at all.
That's a very great comment, right? I think if any of you are on the pre-GitOps side, very valid to have those emotions, and it's great to hear from people on the other side now. And as I mentioned, people like Pinky and others in our community who are very much enjoying the value of GitOps using Flux today. So it's good to look back at how something might have seemed scary at the time, but now it's very smooth and part of daily operations. So a quick mention to community, because I want to close out with some great comments that you had. I was there, I've been at Weaveworks a while, and it was great to kind of join. We're like, okay, we've got a bunch of these open source projects, and Flux was one of them, as we mentioned, built for something very pragmatic. And we hadn't even really put energy into, should we grow this community? And yet it was growing kind of organically on its own. And then when we kind of said, let's do the minimum possible, just do a few things and see what happens, it was quite fun to see the response. I was joking how like you must feel like a proud parent to see all the love and excitement, and then it made sense for us to start saying, okay, let's take this seriously. Let's talk about the CNCF. Let's go through those many steps. How has that felt for you?
It is a bit like that. Like being a proud parent. In fact, one of the things I'm most proud of is actually less about the code and more about the sort of tone and mode of operation and the sort of ambiance of the community, which I really enjoy, and the way we've got a governance which is very consensus oriented. So it's about getting agreement from everyone that feels they have a stake. Not all projects do that, but I think it's really, really important. It's something that I'm really pleased that we managed to all agree on having that governance.
Yeah, definitely.
And I think the joining the CNCF was definitely the turning point. We hit 1.0 and joined the CNCF and did a major code change, all in the space of a very small number of months. And it really, really changed the focus of the project from just being the thing that solves our own problem, that other, happens to be handy for some other people, to something that where we were trying to be very deliberate about having a community and bringing on other people that have a stake and getting them to, tell us what they want from it as well.
Yeah. And we have 1 minute left before our final topic, but I want to give a quick shout out. You've been enjoying Daniel Holbach's music, and Daniel Holbach is the community manager. Great kudos to getting us through all these steps as well, through incubation and now getting close to graduation. So to close out, we've been talking about how Kubernetes or GitOps is one natural evolution of Kubernetes. And I think the work that you and the team and the community has done around Flux is so reflective of that. And so this constant idea, right, of observing the ideal state of a repo. You were talking about how GitOps doesn't have to stop there. There's a whole future. How are you seeing potentially what GitOps may be in the years to come?
Yeah, well, I agree. Kubernetes is a big part of GitOps. It's not the only way to do it, but it's
Tamao, I just want you to know you're not frozen, so you're not confused. I think he might have frozen.
Oh, okay. So it wasn't me.
No, I wanted you to know that it wasn't you because I saw your expression and I was like, it's not you.
Yes. Okay, thanks for letting me know.
No
So Michael is getting to the huge final conclusion about the future of GitOps, and maybe it was too much for the internet to take. Well, I'll close out for Michael. I think Michael was sharing some great ideas about how with cluster API and the new developments that, you wouldn't be doing GitOps just for particular repos being an ideal state for others, but one cluster could be the ideal state for multiple clusters. So there's just we're just getting started with GitOps, and hopefully that's exciting for many people in terms of what you might benefit from this starting stage moving forward. So with that, am I doing the next one? Yes, I am. So we are going to have one final short talk before we get into the vendor showcases. And for this, Kingdon Barrett on our team will be joining us. And I think Kingdon has the slides. Kingdon, you want to share your slides?
No problem. Here we are.
So this talk, if you've seen the schedule, is on enterprises, loving Flux, why they love Flux, and what they love about it. So again, I've mentioned my name is Tamao Nakahara. I run the developer experience team here at Weaveworks, and I'm very excited to have. We can see your screen, Kingdon.
Sorry about that.
We lost the slide.
Wasn't quite filling the screen up.
Yes. And Liz, you're on the screen, by the way.
There we go. That's better.
So my name is Tamao Nakahara. I run the developer experience team here, and I'm really glad to have Kingdon Barrett here on our team. Kingdon, how are you doing? And tell us a little bit about yourself.
Great to be here. Thanks for that nice introduction, Tamao. I'm Kingdon Barrett. I'm also on the developer experience team at Weaveworks. I'm an open source support engineer, and I'm also a Flux maintainer.
Excellent. So if some of you just joined or you've been joining earlier, wanted to share like today's event for many of you who might just be searching GitOps online and saying, well, how can I get started? So it's really important for us to share all these amazing vendors, Amazon, D2IQ, Microsoft, Red Hat, VMware, Weaveworks, right? These are all GitOps solutions that you might consider. And maybe you're already using Azure, maybe you're already on AWS, and you don't know that like, oh, these are options that I have for me already. So hopefully this will be a helpful event for you. So for those of you, like as we mentioned, we hope there's a current future and a future where you just click a button that says GitOps and you trust your vendors to do that. And in many of these cases, we're on our way to do that. But we just wanted to share with you, of all the speakers today, just a little bit of what's under the hood. In our case, it's a great celebration that all of these vendors speaking today are using the CNCF Flux project. And hopefully you won't care. You'll say, I just trust that they're using the best technology and I have a great experience. But we thought it'd be helpful to reflect a little bit on the many companies who have been practitioners of Flux already and of GitOps already, and why they've trusted Flux and been enjoying GitOps with it. So for a little bit, let's just set the stage. Let's not assume everybody knows what GitOps is. It's important to always make some definitions. So Kingdon, share with us a little bit. What's GitOps?
Sure. GitOps is a way of managing your infrastructure and your applications so that the whole system is described declaratively, version controlled, and most likely that's in a Git repository, and also with automated processes that assume that that assure that the deployed environment is actually matching the state that's specified in the repository. If that sounds like a mouthful, GitOps, maybe a little bit simpler explained, is operations by pull request. So this is an operating model for continuous delivery of cloud-native systems, leveraging version immutability and declarative configuration. So go a little bit beyond that. There's a formal definition for GitOps. It's by the CNCF working group that's been established for some time. And as of KubeCon, they've formally released version 1.0, which is a signal of Open GitOps, the standard, being ready for mainstream consumption. And this is a vendor neutral definition. So there's a number of companies that have been involved, Weaveworks being one of them.
Excellent. So these are just some of the few logos of companies that have been using Flux in production. If you go to fluxcd.io, that is the website for it. And so hopefully you're in good company of these companies who have spoken and shared their various use cases. And we'll be having more and more use cases out there that hopefully align with the needs that you have today. So want to just cover some of the top reasons that enterprises love GitOps and they've been enjoying Flux, and why the many vendors here have wanted to provide GitOps for their customers using Flux. Some of the top things, right? Of course, security and compliance, very, very important. The GitOps methodology and the way that Flux is designed makes that possible in a very, very powerful way. If you've seen some of our past GitOps Days events, we've talked about the DORA metrics and how development velocity is incredibly important and strongly aligned to companies that have shown great success in terms of revenue and going IPO and getting investment. So GitOps, especially using Flux, is a very, very important tool to increase that velocity. And CapEx and OpEx savings, we've had many users share when they're trying to argue for the business needs, whether it's using your team members to the best of their abilities toward innovation versus repetition, or making the best of your infrastructure investments. GitOps helps with that very, very much. And so again, right, automation is a key part of being able to focus on innovation.
So I'm going to talk for a second about how Flux delivers enterprise-grade reliability. Flux has a stable API, which we announced in June. And this is important for both systems builders, cloud vendors, but also end users, because it means we're not going to pull the rug out from under you. The interface will not have breaking changes after this point. Flux is also considered very reliable because it is well tested. They're end-to-end tests that cover all of the features. So besides the interface, you can actually be assured that the Flux behavior will remain consistent. And Flux itself is designed with an extension of Kubernetes approach that uses custom resource definitions. So this means that the reliability of Kubernetes is actually inherited by Flux. The reliability of Flux is also validated through the CNCF. We heard Ihor mention earlier that Flux is in incubating status as of March 2021. and we're marching rapidly towards a graduation.
So excellent. Wanted to cover some of the ways that Flux delivers these great enterprise-grade GitOps capabilities. So again, if you go to the Flux CD.io site, if you are interested in learning about Flux, at the top we have sort of the 8 key points that are important to know. I just want to highlight a few of them. So like the very first point that we have here, some people think that GitOps is only for apps or only for infrastructure. And it's really important to know that we have so many great users who are using Flux for both their app-based GitOps as well as infrastructure. It's just really flexible and brings the benefits to all the different types of teams that need to use it, whether they're directly implementing it or consuming it. I'll jump to the third point here too. I know it's a very valid concern. It's like, well, we just spent years investing in Jenkins. It's all set up, or we already have GitLab. It's really important to know that Flux works with your existing tools. It's been very strongly designed to be able to work that way. Kingdon, in fact, has written great documentation on using Flux with Jenkins because we know a lot of users care about that. And then on our next slide, a few more points I wanted to cover. Again, the top point, really important to know that Flux is multi-everything. It is multi-tenant, multi-environment, multi-cluster. So it's really been designed by the people that you've met, like Michael. Kingdon's contributed. I think Ihor listed out the many maintainers, such as Stefan, Hide, and others in the community. And many more that we've hired, in fact. Shout out to the roles if you're interested. So we've really built a robust system that is capable for doing things that you need today and really thinking to your needs in the future. And finally, I'll jump down to the third point. Again, it was really important for us to not have an open source project that kind of was out there offering a few things. We really wanted to put it out there in the CNCF as an offering. And as Ihor mentioned as well, there's a GitOps working group in the CNCF. So this is very much about a broad practice, and Kingdon will talk a little bit about that in a minute.
So earlier I mentioned the open GitOps principles, and Flux, I wanted to highlight that Flux delivers on all of these principles. We're just going to take a look at them really quickly. So these should all sound familiar. If you were paying attention earlier when I described GitOps, these are the actual principles from opengitops.dev. And we talked about version store, automatic reconciling. All of these are features of Flux. So if you're using Flux or a product that's based on Flux, this is what you'll get out of the box. Also, before we go to that, I wanted to mention that Flux has recently added support for server-side apply, which is a new feature that was made generally available in Kubernetes 1.22. So that was just in August, just to highlight the fast pace of Flux development, always adding new features.
So I wanted to spend just the remaining couple minutes on these early adopters, perhaps, who've been really enjoying GitOps on an enterprise level, to hopefully help you hear from them directly what benefits they're having by using Flux. So our most recent, there was a blog post in the CNCF blog, if you want to find it, by the US Department of Defense. If you may know that they built a DevSecOps platform so that all of the various departments, I believe, if I get it correctly, like the Army, the Navy, the Air Force, their software developers could have a secure place to develop whatever apps that they needed. And it was really amazing, like how much they were using open source. I think it was like 99% of the projects used, the tools there was from the CNCF or other open source areas. And so it was really exciting that for them, it was a clear choice to use Flux. Their particular use case, they really are tied to Helm. And so they wanted to take advantage of the Helm ecosystem. And since Flux is designed well to work with Helm, that was a clear choice. And I loved how one of the contractors said how the Flux API is crazy stable. So as Kingdon was mentioning earlier, the reliability is really important. And it was great to hear from an actual user about how that stability is actually played out. We'll go through quickly a few others. If you come to our previous GitOps days, you've heard speakers like Vuk Goinich of Deutsche Telekom saying how by using Flux, they were able to create a self-healing platform in which they could focus on really using their employees to the best ability. And so you want to focus your humans on innovation versus on repetition, right? And even pragmatically, the story shared how they had fewer tickets. So that's a very tangible metric. Similarly, Under Armour, we had a speaker from there who used to be there and shared similarly how you don't want to have people doing the repetitive tasks. You want them focused on innovation. And especially when you need to scale, you don't want to just throw bodies at the work. You want to be more strategic. So being able to have GitOps practices using Flux meant that it helped with retention, right? You can retain employees because they had the satisfaction of knowing that they're adding value, they're spending time on learning and innovating for you as well. And a few more, we have great case studies from Tidepool, an organization that, again, security and compliance is really important. And since we're using Git, you have an audit trail and it lowers your risks as well, because you know that you can see what went wrong and it makes troubleshooting more streamlined. And finally, to close, we have a great quote from Global Freight Solutions, where there really was a low cost of entry. So for many of you, if you are just getting started with GitOps today and wanting to see what the value is, here's some users sharing how they had quick and great value right away. And so they didn't really feel like it's for early adopters or startups or unicorns. It really is ready for the enterprise today. So I hope that you enjoy the rest of the event of these great vendors. And thank you to Kingdon for joining me in this talk. And looking forward to the rest of the event where you can see all these great vendors who are using Flux to deliver GitOps to you. So with that, we will cut to our first vendor speaker, which is the employer of Kingdon and me, Weaveworks. This 2021 has been a fantastic, exciting year because as we've reflected with Michael from the beginnings of Flux and reflected through the journey through the CNCF, we as a company at Weaveworks have built Weave GitOps, a product that is built on Flux. And so we're very excited to have first Liz Warner, the SVP of engineering from our company, sharing a few words. And then after that, we'll have Mark Ram, who will be showing GitOps at work. So Liz, how are you doing?
Hey, I'm great. I'm really happy to be here.
Excellent. And Liz is hailing from the UK as well, right? Got many UK people, well as well as from our other speakers. I'm hailing from Oakland. So great, Liz, tell us, you've joined our company during this exciting time and tell us your thoughts about Weave GitOps.
Right. I'm happy to do that. Yep. So the accent is a trick. I'm UK based. I've been UK based for about 10 years now. So I'm Senior Vice President of Engineering at Weaveworks, and new joiner, just joined this summer. And just beyond delighted to be part of the GitOps company. I'm joining after a couple of decades as a technologist, in particular the past 10 years or so as a technology leader, again, in the UK. So I'll be introducing my colleague, Mark Ram, who's Director of Product here, and he'll do a demo of Weave GitOps. But before I do that, kind of in line with what Tamao and Kingdon have been saying, I want to talk a little bit about my personal journey with Flux and with GitOps and how I see the benefits of GitOps. So I've been perhaps unusual and definitely lucky enough to use GitOps or to lead the practice of GitOps in a couple different roles. And I want to talk about one of them in particular. So I got to know GitOps and I got to know Flux a couple of years ago when I was interim CTO at a neobank here in the UK called Metal. So there's for folks who don't know or in this region, there's kind of a trend going on just to spin up new banks. So new kind of modern app-based cloud native banks. And about half the time, frequently, they're backed by larger incumbent, banks or enterprises with a real hunger to modernize. Now we've got case studies on the Weaveworks website about Metal and Steve Wade, who I know some folks on this call already know. Steve was the platform lead who brought GitOps to Metal. He's written some case studies, like he's written elsewhere online. We can definitely, you can go into the details of what we did, which is not what I'll do here. But I want to kind of talk about the problems we were looking to solve and why we went towards GitOps as for cloud native operations. So as Metal, we were a group really designed to be forward thinking. So we had not only an opportunity, but an obligation to kind of find best practices around software development, around software architecture, and most critically for this conversation, around infrastructure and cloud native operations. So we had a bunch of jobs to do. You know, we were very busy from early on designing and building and scaling a microservice-based application, you know, standard good practice, nothing surprising there. We were also building our communities of practice. So we wanted to deploy this complex banking application many times a day and deploy it safely. We wanted, and in fact, we needed fast and painless error recovery. And we wanted self-documenting deployments that people in our engineering communities could use as a reference for understanding the state of our system and the evolution of that system. So with all these needs, GitOps made perfect sense. You know, it gave us a way to automate our operations and kind of continually reconcile those operations against the declarative model of the system that lived outside the system. So, you know, unsurprisingly for us, we stored that model in Git. So when I was at Mental, this was a few years ago, we used the first version of Flux. And it's been really exciting to watch the progression of Flux since then, of Flux and of Flagger. It was, I know Tamao mentioned that Flux made it into the adopt category of the CNCF Technology Radar, you know, sitting there next to Helm. That's an amazing place to be. It's really nice for me as someone who's been a GitOps fan person for a while to join a company that's dedicated to continuing to support Flux as an open source project and to support the Flux ecosystem. So as Tamao mentioned, we are hiring. If you use your favorite search engine to search Weaveworks careers, you'll see roles posted. There's opportunities to work with the creators and maintainers of Flux and Flagger, and also to work on the Weave GitOps products. So we are dedicated not just to Flux, but we are dedicated to Weave GitOps. So we've got Weave GitOps Core, which Mark will be demoing in a minute, which is a free open source and opinionated GitOps product. And we think it's got a pretty great developer experience so far. And Weave GitOps Enterprise, which extends those capabilities onto a continuous operations product. So exciting times. I'm delighted to be here at the GitOps company. And I would love to introduce and hand over to Mark Graham, who will show you some of what Weave GitOps does.
Hello, everyone. I'm Mark Graham. Just give me 1 second. I will share my screen. So no, not share, present. All right, can everyone see? Looks like it. So I just wanted to talk a little bit about Weave GitOps and how that relates to Flux, and then show you a little bit of the Weave GitOps workflows and what's involved in Weave GitOps. We already sort of had an introduction to Weaveworks, so I won't go through this very much. The key goal of GitOps in general and of Weave GitOps and Flux is to reduce the number of operational incidents, the number of failed deploys, increase the ability to roll back quickly, so reduce mean time to recovery, and increase the deployment frequency by making it easier for developers to get changes into production in a robust and reliable way. I have been toying with the tagline of Weave GitOps that it's Kubernetes native, Flux native GitOps platform. We built on top of Flux so that you can get all of the features of Flux out of the box. We built on top of Flux because Flux is the most powerful GitOps platform that there is. And we built on top of Flux because we want to make the application and cluster operations experience with GitOps more readily available, more easy to use, and bring together a whole product that involves not just deploying your app with GitOps, but connecting that to CI, connecting that to your workflows, connecting that to some observability so that you can understand what is happening in the cluster and deal with issues when they go wrong. Weave GitOps really comes in two flavors, teams or enterprise and core. We've targeted, so Weaveworks has developed a GitOps maturity model, moving from GitOps maturity level of 0 to 3, where 0 you are GitOpsing a single app, and as you move up the maturity cycle, you're GitOpsing more and more. You're adding policy, you're adding tenancy, you're adding more complex management of larger GitOps deployments. You need tenancy so you can avoid application operators stomping on one another by accidentally deploying on top of one another. You need cluster management. If you're going to have large fleets of clusters, you want to manage those with GitOps as well. And Weave GitOps is designed to help fulfill all of those things in a slightly more, we have a set of opinions that we include on top of Flux in terms of repository structure and layout, in terms of how you can work with the product. And we have added an application level abstraction, which is the beginning of the GitOps tenancy model of Weave GitOps. Any questions so far? I do not see any. Oh, it's going fast now. I don't know what happened there. So we're going to start with Weave GitOps core and how we can add applications and manage a set of application teams in different repositories in the same cluster, gives them the freedom to deploy the workloads that they would like to deploy, while making it easy to get GitOps installed on a cluster or get things going, and give people a UI that lets them see the status of their application deployments. So in general, the challenge is increasing developer velocity without increasing the number of operational incidents and increasing the load on the operational teams. So we want to a resilient and automated system here. The important thing about GitOps is that it is a resilient system. It uses Kubernetes goal-driven deployment objects and automates that and does continuous reconciliation. So you know what state your cluster is, you know whether it's in the state that you expect it to be, and you can make changes to fix problems if there are problems. And the goal here is to increase the mean time. I don't think we want to increase mean time to deployment. We want to decrease mean time to recovery and increase resilience, increase the chances that you will not have an error. So here's a quick slide showing Weave GitOps core. It has a set of applications that are deployed. I'll be showing this UI here in a second. And then it gives you information about the Kubernetes objects that belong to that application and how they are connected to the cluster and what their status in the cluster is. So I'm going to escape out of this slide. I'm going to go over here. So while I was fixing that, I went to WeGo example and cloned a repository that has a sample app. So then I'm going to check this out. Oh, right. Check out clone. What am I doing? Okay, so I have now a pod info repository. Pod info is just a sample app that we often use for development or for demos. Consists basically of two services, a front end and a back end service, each with a deployment YAML. Standard Kubernetes files here. Nothing that is not Kubernetes native going on here. I've already installed at GitOps in this cluster, which is done with the command GitOps install, and that will install Weave GitOps and into the current cluster from your Kubernetes kubectl context. So now I'm going to actually in there. So what this is going to do is go ahead and grab the current Git upstream Git repository for this local checkout, set up Weave GitOps in the cluster to synchronize that application, store the GitOps automations in the application. We have several options here. You can store the automations in the applications. You can store the automations in a sort of central platform repository, so that we can support and you can store the individual apps in any folder branch repo combination. So you can have a mono repo, or you can break repositories down, one for each application team, and then you can control access to who can update those apps in the cluster by controlling access to those repositories. So I gotta authenticate against GitHub here. To finish this, and then what's going to happen is Weave GitOps is going to automatically create a pull request for me in this repository. So we'll see that start happening here in a second. Also created a deploy key so that it can hand the deploy key to Flux so that everything just works. If I come back over here, there should be a new pull request. The pull request adds, as I said, the sort of automations for Flux, sets up the Flux sync and the Flux customization controller. So I'm going to go ahead and merge this. So then over here, we can't see it happening because it's happening in the background, but if I flip over here, I should be able to see I now have a new pod info deploy application. You can see the status of this application here in the UI. Zoom out a smidge. You can see all the resources that exist right now. So customize is there. Flux is set up, but is not yet synchronized into the cluster. So I will come back to this in a second. Any questions about this so far? I can have multiple applications. I can see the status of my applications. In the cluster, I can see what is going on. This is sort of the first version of the UI. We will be iterating on this as we go. It's application centric so that you can enable application teams and enable application operations in a very lightweight and Kubernetes native way. Any questions on this? No. All right, so I could go in here if I wanted to and make a change to the deployment. I could say I want to have more pods running. I could change the background color in here. I'm not going to spend time doing that. I think that's all sort of standard GitOps stuff that everybody in this audience is probably fairly familiar with. But if there's any questions or anybody wants to discuss at a later time, I'm on Slack and you can ask me. I'm happy to show you some more detailed demos. So then I was going to switch over to Weave GitOps Enterprise in a second. But before I do that, I'm going to come back here and talk slides for a second. So as I said earlier, Weave GitOps is designed to fit both the needs of development and platform teams. It is designed to scale GitOps usage within the organization. So the core, Weave GitOps core is open source. It is free software built on Flux that anyone can use. Weave GitOps Enterprise is a commercial product that allows you to extend Weave GitOps core with a variety of things, like that coming soon is a more advanced tenancy model based on Weaveworks' previous team workspaces, and various things. The key thing that is in Enterprise that many people are interested in is CAPI-based fleet management. So we can create clusters from templates. We can use Weave GitOps supports out of the box CAP-A, CAP-D. Other cluster API providers are known to work, and you can create templates for any CAPI provider and create clusters sort of in an automated way, enable self-service cluster creation for operations teams, either application operations teams, if you're doing a sort of hard multi-tenancy, each app gets their own Kubernetes cluster, or business units. We have folks who want to use it that way as well. Everything here is standard Kubernetes. The templates are Kubernetes resources. You can control access to create and manage clusters on a template by template basis using Kubernetes RBAC. So you can create a cluster very easily. I'm just going to show a quick video of this just because it takes a little while to create clusters. So here he's clicking create a cluster. We're going to create a CAP-D cluster. Type in the cluster name. Other fields are automatically filled out for you based on that. You can choose, in this case, we're doing CAP-D, so it's the Docker namespace that we want to use, what Kubernetes version. It creates CAPI cluster manifest for you, which becomes a pull request, which you can then go over into GitHub and approve. So you can have cluster, a team say, oh, I would like a cluster of this kind. You can have an operation team check that before it actually is created. So once the cluster is merged, or the cluster definition is merged, the CAPI controller there will create the cluster, and coming soon in a Weave GitOps Enterprise release, we will also be installing a set of profiles, a set of default cluster components that you would like installed with that cluster at install time, so that you can create a cluster with all of the platform components that your application team might need. I guess I have a couple more slides here to talk through. So we have this concept of GitOps packages, largely based on Helm charts, but with a upstream GitOps relationship. So you can say, be notified when there is a security vulnerability that has been updated and you need to update your clusters, etc., where you can pull upstream changes into your Git repo in a very GitOps native way. And where you can manage a set of cluster components at cluster creation time. Profiles or GitOps packages can also be used in a variety of other contexts. You can have a Cassandra or a machine learning profile that extends the capabilities of the platform in whatever ways make sense to you. And this is really important because this provides a DevOps style single point of truth for collaboration between application and operation teams about the capabilities of the platform beyond raw Kubernetes. You can say, I need Prometheus, I need this version. You can say, I need a version update for my for my app metrics for this reason or that reason. Operations team can see that as a pull request. You can use separate repos. You can use code owners in GitHub or GitLab equivalent functionality to control who can make changes to what clusters and what profiles in what clusters. And then I guess finally, Weave GitOps provides a package solution. We don't just give you some software and leave you to figure everything out on your own. We have consultants who have a lot of experience doing large scale GitOps deployments and GitOps migrations with media companies, banks, all kinds of folks around the space. If you have any questions on any of this, I would be happy to answer questions.
Thanks a lot. Thanks for surviving through all of that, despite the house alarm and such.
A little crazy.
Yes, it always happens, right? It just works out that way. I'm scanning the GitOps Days conversations, and there might be some just more broad questions about practices that maybe would be applicable to talking about Weave GitOps. We just have a few minutes, but you know, if one person was asking, like, do I have one app per repo? And others asking about if I have a lot of apps, is it one repo per cluster? Are there conflicts? So there's a lot of chat already going on, but I thought maybe you have some opinions of.
Well, I mean, we have seen in a number of organizations that is like Weaveworks itself. In order to get a new repo, I have to file a ticket. And someone has to create that repo for me. So often I will run multiple apps in the same repo. I keep them in separate folders. I often have a branch per lifecycle stage. So I'd have a branch that represents changes that are in the development process, changes that are in QA, changes that have gone to staging, and changes that have gone to production. And I can just merge changes through those branches across the clusters that are impacted by that branch. So that's the sort of out of the box default way that I use it. But you can, I just demoed keeping each app in a separate repository so that we can control access by team. Whichever way works for you and your organization should be supported by your GitOps tool.
Excellent. Thank you so much. So with that, we are going to get ready for our break. So thank you, Mark, for joining us from your location. My trusted co-host, Pinky, is back.
Ready for some more music?
Yes. So if anybody joined for our pre-show and the opening couple of minutes, we were grooving to Daniel Holbach on our team, who had, I guess now it's still unofficial, but we've enjoyed the name DJ Desired State. Daniel, of course, has every right to rename, but we had a vote in the early GitOps days. So yes, we have about a 15-minute break. Hopefully you can all grab some water, whatever you need. That was our first of several vendors that are using Flux to provide GitOps to you. So we're excited to hear the many others who are waiting in the wings. So Pinky, what did you think about our first couple talks reflecting on the beginnings of Flux?
It's been so cool to hear about it. Yeah, I'm most excited to hear that it's almost graduating. That's really cool. I didn't know that.
Yes,
So that's awesome. And then the enterprise offering is really exciting to hear about too.
Yes, thank you. So yes, as I mentioned, Daniel has been at the core and really leading us through our CNCF journey, and now is also sharing other skills with great music. Daniel, take it away.
hop spare it out. Every time I list the track, I bring it back. Wish the crowd for a minute, but if you doubt, come around when I mean you're down to see the fact. Bass in the back, bouncing like a low rider. Swing to the right, to the left, I'm bringing it back. Nod your head, turn around, make it clap. Shake that ass while I hit it from the back, girl. Every time I list the track, I bring it back. Wish the crowd for a minute, but if you doubt, come around when I mean you're down to see the fact. Bass in the back, bouncing like a low rider. Swing to the right, to the left, I'm bringing it back. Nod your head, turn around, make it clap. Shake that ass while I hit it from the back, girl.
from home, girl. My feet are hurting mighty bad. Now I've been walking for 3 days and 2 lonely nights. You know that I'm mighty mad. But I got a woman waiting for me that's gonna make this trip worth a while. You see, she's got the kind of loving and kissing or make a man go stone wild. So I got to keep on walking.
Thank you, Daniel. That was awesome. That was so much fun.
Think
All
you're
right.
having a good time?
Yes, that was awesome. I
So
love
great.
his vibe.
Yes, yes. It was
All right.
cool. It was like kind of more
Yeah.
mellow, loungy earlier this morning. Now it's a little bit
Yes.
more upbeat.
And I love how he's getting down too. He's like over there dancing. It's great.
Absolutely. Thanks for co-hosting with me, and we're going to get right to it. So, Pinky,
Yeah.
introduce our next guest.
Yeah, so next up, we actually have Microsoft. So we have Jason Hansen, a principal program manager for Azure Arc at Microsoft. And then we have Jonathan Innes, a software engineer also from Microsoft. And they're going to talk about GitOps with Azure Arc for Kubernetes. So go ahead, take it away, guys. Thank y'all.
Awesome. Thanks, everybody. Super happy to join. Thank you, DJ Desired State, for rocking out. I want to take you everywhere with me now for all the interlude music. My name is Jason Hansen, and I am a program manager working on Azure Arc. And I'm also joined by Jonathan Innes from the engineering team, who's going to dive in and show us all the good stuff that we've been working on. Now, I want to first set a little context. So Azure Arc was originally sort of born from a set of customer challenges. Folks have lots of applications written in lots of different languages, different application runtimes, various deployment patterns. And those applications need to run in lots of different places. So that can include existing data centers, hosting providers, branch offices, a server under Mary's desk at a remote location. The broadest definition of edge. And increasingly customers, are using a multi-cloud approach as well, whether or not they want to use capabilities from a specific cloud provider or they want to get close to their customers using a specific vendor. Now, customers are asking how can they operate in this environment? How can they ensure that they've got end-to-end security? How can they keep their developers and operations teams productive in this kind of environment? And the suggestion here that Arc is positing is that Azure itself, we built a number of tools, services, and capabilities that help Azure run Azure. And typically those tools and capabilities were limited to stuff that's running on Azure, provisioned to Azure data centers. Now with Azure Arc, what we're doing is we're building a bridge to extend those services and capabilities to stuff that isn't in our data centers. So the server under Mary's desk. Azure Arc helps provide that connective tissue. Now, in the limit, that means one consistent Azure platform that's Azure connected and can span to lots of different locations. And there are lots of different legs to the Arc strategy. We'll save that for another day. Let's get to Kubernetes and why Flux is important to Kubernetes in this context. Now, Arc starts by enabling infrastructure. And again, that's building that bridge to Azure. Now, for Kubernetes, this means deploying an operator into your cluster. That operator runs and securely connects to Azure. That means you can see your Kubernetes clusters in the portal sitting right next to your AKS clusters. And we can start to unlock some Azure management services. Now, this means at the end of the day, one place for cluster inventory, one place to monitor, one place to establish policy and control access. And all of that can be done from Azure interfaces, APIs, SDKs. And additionally, we want to meet you where you are with your Kubernetes investments, your distro of choice. So any CNCF conformant Kubernetes cluster can be attached to Azure. And that's all great. Now, I've got a bunch of kube stuff all over the place. Now I want to make sure that it's configured consistently, that I've got all the right namespaces, the right applications deployed, the right operators, and we needed a great tool to do that. And so we looked to the ecosystem, and this brings us really to Flux. So we've integrated Flux as part of the Azure platform. This means that you get all of the Flux goodness that you've seen today and will continue to see, integrated and Azure supported, and we use the upstream bits. You can use this integration on any AKS or any Azure Arc enabled Kubernetes cluster. Now you can deploy Flux to those targets using the Azure CLI, by ARM template, by policy, or our APIs. That gives you kind of an out-of-the-box installation experience with upgrades and updates as part of the platform. Now, because this is Azure integrated, this also means that we can start to unlock some of those additional Azure management services. And one of the things that I'm particularly excited about is Azure Policy, which allows you to author policies and have the Azure Policy Engine enforce that state across your infrastructure. So, for example, you can make a statement, any Kubernetes cluster that attaches to my Azure subscriptions or resource groups needs to have Flux installed, and that Flux should be configured to point to a specific set of Git repositories. And the Azure machinery and the integration with Flux will make all of that happen. And your compliance or your governance folks can sit in the Azure policy dashboard, and they can view and monitor resource compliance across the board. And of course, with Azure, that's inclusive of our Kubernetes clusters, as well as any servers, virtual machines, and platform services. And again, with direct integration into the Azure portal, we're hoping to make this as simple as possible. So with that context, I definitely want to go ahead and kick it over to Jonathan to dig in and show you this stuff in action. Jonathan?
Thanks, Jason. I'm going to go ahead and share my screen and get into the demo. Let's see. Let's pick the right screen. So hopefully everyone can see my screen now. I would hope so. Can somebody just confirm, just so I don't start?
I don't see your screen yet.
Now.
Yes, it is coming up.
Perfect. Okay, I would have started presenting and there was nothing there. Great. So yeah, so I'm going to walk through a little bit of what Jason just covered. The idea here is basically we're going to start talking about how you would go about onboarding Flux v2 and onboarding what we consider a configuration, which is a single source and kind of multiple customizations attached to that source. How you would go about configuring that on a single cluster in Azure. Either a connected cluster, which is the Arc connected cluster, or an AKS cluster. And then we'll also look at the at scale scenarios. So we'll take a look at a bicep template. You could also feasibly use an ARM template to configure, basically provision a ton of clusters at once that all have Flux installed. And then we'll take a look at the policy scenario as well, which will come very soon for Flux v2. And we currently have with Flux v1 and GA in the portal. So here, I'm going to go ahead and pull up a Git repository that we can use for this example, and this is probably going to be one that's going to be repeated a few times today, which is the Flux 2 customized Helm example, which exists on GitHub, and it's going to deploy the pod info application, which we kind of all know and love if we're familiar with GitOps. And here we basically have two layers that we're trying to deploy. We have the infrastructure layer and the app layer. In this particular case, I'm not actually pointing to the public version of this repository. We're showcasing the capability that we have, which is that we're enabling private repositories to be able to connect to GitOps here, because of course, most enterprise customers are using private repos to store all their manifests. So here we've actually have an on-prem Bitbucket server that we provisioned, and we're also using this as a private repo as well. So there's going to be, in this case, we're going to connect to this repository over SSH. So we're going to be using a known host value for the public key as well as a private key to attach to this particular repository. So this is pretty much the high level overview here. And so for this example, we're actually going to show the CLI right now. And we have portal support coming very, very soon for this. And just to point out, this Flux v2 feature right now is in private preview and will be in public preview very, very soon. So a lot of the support right now is, we're having portal support very soon, but right now, most of the support right now is in the CLI and the APIs and the SDKs. So here we're gonna onboard using the CLI. So actually the CLI that we used to onboard is this case configuration CLI. If you're familiar with Azure GitOps at all, with Flux v1, it was AZ case configuration, and then you could dig in here, maybe doing AZ case configuration help and take a look at, you can do create, delete, list, and show commands. Now with this onboarding of the new Flux v2 offering, we have this Flux subgroup here. So if we take a look at the AZ case configuration Flux help, type correctly, we see the same offerings that we had with v1. We can create, delete, list, and show these Flux configurations that we're going to onboard to this cluster. And so here I've already actually provisioned a Arc connected cluster. And so if we take a look at the pods on this cluster, we see that we have all these Azure Arc pods that were deployed. So this is done through the AZ connected K8s command that you would do if you were onboarding a connected cluster. You obviously wouldn't have these agents here if you were using AKS. This experience is consistent across Arc and AKS. So once you have connected to the Azure control plane, you can start enabling with this Flux v2 configuration. So I'm going to go ahead and copy a command over that we're going to use to provision this Flux configuration in Azure. So here we've done AZK configuration Flux create. We're attaching to the resource group GitOps days to the cluster with the name GitOps days cluster, which exists within this resource group. And then we have the name of the configuration that we're trying to provision, which is this private repo example name. And again, because this is a connected cluster, we specify the cluster type as connected clusters. And then here we see we can actually specify a scoping property. So each configuration, this is consistent with V1 as well. Each configuration that's created in Azure can either be specified at the cluster scope or at the namespace scope. So here we want to give cluster-wide permission to the controllers that are applying this this configuration, this source, and these customizations. So we'll give it cluster scope because we want it to be able to apply across. If we wanted it to just have access to a singular namespace, which is the namespace that this configuration was deployed to, we would give it namespace scope permission. And then the namespace that we specify here is all that it would be able to deploy to. Here we give the URL of the Git repository that we're trying to connect to. So this is the SSH version of that URL. And then the known host file and the private key file, as I mentioned, and then we specify some additional parameters that are part of the source spec, and then some customization parameters that are also part of the customization spec. Here with the customizations, we see that we're applying two paths. As I mentioned before, we have an infrastructure layer and an apps layer. And so we're deploying the two paths, and we're specifying that there's a dependency between paths. So again, we kind of get all the Flux v2 goodness that we expect that is the upgrade from v1. So if I go ahead and take this and copy it over to start deploying this thing to the cluster, we're going to see a couple things. So first off, it's going to check if the Flux extension is deployed on this cluster. And what we're doing here is we're actually leveraging the extension platform that exists on Arc, where we're doing essentially the equivalent of a Flux install to deploy the Flux controllers to this cluster. So it's going to check to see if the Flux controllers exist on this cluster. And since they don't, in this case, it's going to start deploying that. And so in the background, while this is running, we can actually pull up another terminal and take a look here. So it's going to start to install the Flux controllers, and it may take a minute for them to come up. So we'll take a second to take a look. I guess in the meantime, actually, I can go ahead and come over to the cluster in the portal and actually show you, if we go to the extensions tab here, for this cluster, we can see that this Flux extension is installing and is going to start to come up. So we actually already see it provisioned here. If we go back to the cluster and grab pods, we see that the Flux system namespace has some pods inside of it. And so here we see the Flux controllers that we're used to seeing. We have the Helm controller, the customized controller, the notification controller, and the source controller that are coming up in this cluster. And then we also have a couple Flux config agents that are coming up as well that are deployed as part of this extension install. And so here, these are the two agents that basically bridge the connection between Azure and this cluster to be able to deploy the underlying Flux objects to the cluster. So it's doing the creation of this extension. And then if we take a look here in a second, it should tell us that the extension has completed install. And then once that installation has completed, then it will then apply the configuration object, which is essentially the source object along with the customizations that it needs to deploy to the cluster. So it's going to have to round trip back to install the extension. And we'll wait for that to happen. So here it says Microsoft.Flux extension was successfully installed in the cluster. And then it's going to create the Flux configuration that we specified. And again, this can take a few minutes for it to do the round trip. But here we see when we create a configuration for the first time on a cluster, we do the installation of the extension. After you have installed the extension once, it's going to know that that extension is there. And so subsequent installations of this configurations on your cluster won't cause it to have to go and install the extension again. So you only have one set of these controllers on your cluster, which is kind of the Flux architecture for installing these controllers at a cluster-wide scope. If we take a look at the pods again and wait for it to come up, so we'll take a minute. To bridge the connection. So here we see we're actually doing container creating on this pod info application. We're bringing up the ingress controller for Nginx, and then we'll also bring up the Redis backend in a second, which is here. So we have the Redis backend and the Nginx controllers are up, and then the pod info application is up and running. The intention here was that we would install the Helm release objects that we wanted to install from the cluster. So if I get the Helm release objects on this cluster, we see that the reconciliation is in progress and is succeeded for this pod info object, and the Redis and Nginx are reconciling and successfully reconciling with this cluster. So we were able to successfully install the Flux controllers on this cluster, and additionally connect them to the Git repository that we had intended to deploy these manifests to. If we want to dig in under the hood and take a look at what we're actually deploying, here we can see that we've created a Git repository object that's connecting to this URL and has the name of the configuration that we applied. And then additionally, if we take a look at the customization objects, we see that we have 2 customizations that match up with the items that we wanted to deploy as part of the ACK's configuration flux command. So now if we take a look, we can actually take a look in the portal and see the GitOps information from a high level at the cluster level. So here, if we take a look and click the GitOps tab on the side for this connected cluster, we actually see the configuration name is here, and then we see a bunch of fields at a high level here. So as you install configurations, you'd be able to see all your different configurations come to the side here. And at a high level, you can see that the operator state, which in this case is the success of actually installing the configuration on the cluster, is in a succeeded state. So it was able to successfully provision the source and the customization objects to the cluster, as well as some like RBAC and secrets and things like that. And then additionally, we see that the sync status is in a compliant state. And this status is showing you that the manifests that you intended to apply to the cluster have successfully applied. In this case, it's looking at Flux objects specifically. So all the Flux objects that you applied, any of the customization objects that we created as part of the managed offering, the customization is going to attempt to apply those YAMLs underneath whatever path you specified. And then if it succeeds to apply that path, then it will show in a compliant state. So we can actually dig into the configuration here and get some more information. We see again, the compliant state of this configuration is compliant, and the install state is succeeded. We also have the 8 configuration objects that we're basing this compliant state off of. So if we dug in and looked at the configuration objects that I was referring to in the past, we can see all the kinds of these Flux objects that we had applied or were inadvertently applied by the customization to this cluster. So these Helm releases and these Helm repositories that were applied. And we see they're all in a compliant state, which essentially means that they're in a ready state on the cluster and have succeeded. So if any of these go into a non-compliant state, which would mean that they're not in a ready state anymore, we could take a look and eventually we'll be able to dig into the specifics of the conditions on this object to see specifically why things have failed to apply and what specifically is not applying successfully, so we can remediate that. And then additionally, if we want to take a look at the customizations that we applied through the managed offering, we can see the paths and the customization names and all the information that we specified there. So that's the UI experience and how you can also configure alerting on these things. So again, if you see that the compliant status, the sync status is gone from compliant to non-compliant, you can have alerts fire based on that, so you can remediate those issues as they come up. So next, we're going to take a look. Basically, we've just shown what a single cluster offering might look like, but let's say you want to automate a bunch of different clusters to deploy a bunch of different instances of the Flux extension and deploy configurations to all those things at once. You can do that through ARM templates now, as well as a bicep template, which is what I'm going to show you here. I'm not going to deploy this bicep template because it would take a little bit of time, but I'll show a high-level overview of it. Essentially here, we're creating a managed cluster. So this is an AKS cluster in this case, instead of a connected cluster. And so here we've given a resource as managed cluster. We've given it a name. We assign it an identity, which is required for this extension, the extension platform to work on top of the managed cluster offering. But we assign it an identity, and then we give it some additional properties that are required for the AKS cluster. Additionally, we can then add the Flux extension, which is again the Flux controllers and the Flux config agent and things like that on top of this AKS cluster. So we specify another resource type, give it a name, and give it an identity, and then specify the extension type, which this is the piece here that tells it to install the Flux extension. So here we install the extension at the scope of the managed cluster and would install it on this managed cluster. And then finally, we can specify the configuration resource type, which should come after the extension resource type as it did in the CLI. And we give it a name, apply some properties to it. So here we have, again, the scoping property, namespace, source kind, the URL, and other properties that are specified with it. And then that will apply. And we also tell it to depend on this extension object above. So it will apply this after the extension, which it should. And so here we are applying the configuration object, again, at the managed cluster scope. So with this fairly simple bicep template, we could iterate through this template either through scripting or through the bicep template architecture itself to actually deploy a ton of different AKS clusters that all have Flux installed on them and all have a configuration that points to a single Git repository with as many customizations as we want. And we can, of course, deploy any number of configurations to all these different clusters to kind of get, again, that at-scale experience that you would expect with the Azure control plane. And so the last thing here is the policy scenario that Jason laid out. So here, if we go over to policy, we can actually see how we can take it another step further beyond this ARM template, beyond this bicep template idea, where we're actively monitoring whether these configurations are installed and whether the extension is in a healthy state. So here, this is a V1 policy that we're going to show. We don't yet have V2 policies, but that'll come very, very soon. So after, over the next few months, when we do public preview, we'll have the policy that will be offered there as well. So you'll be able to also do this with V2 deployments as well. But here we have a V1 policy that we've created. If we dig into this assignment here, which is assigned at a resource group level, we can see all the parameter details and all the information that's part of this policy. Essentially here, we're saying that we want to connect to this repository URL. And all this information about the configuration resource type and things that are specific to Flux v1. What this means is that whenever we deploy a new connected cluster to this resource group, which is specified at the policy scope, it's being a little slow, which is specified at this policy scope, whenever we deploy a new connected cluster, or whenever we first assign the policy and there are already connected clusters within that resource group, it's going to automatically check whether those resources are in a compliant state. And if they aren't, then it'll deploy the configuration to those clusters automatically. Additionally, it'll actively check consistently over time whether those are in a healthy state, so whether those resources are in a compliant state from the policy perspective. So if we go again back to the policy assignment and take a look at the compliance of this policy by clicking on View Compliance, give it a second to load. We can see that in this resource group, we have 2 compliant resources and 1 non-compliant resource. So here we can take a look at this non-compliant resource. We could click on this, go to the resource, or we could either see why it's not compliant if it doesn't have the configuration resource there, which is the case in this particular scenario. And then if it doesn't have the configuration resource there, which is the Flux v1 configuration, we can then click this create remediation task, cause it to re-evaluate and redeploy things if they don't exist, and then bring it back into a compliant state. If we go back to this level, a bit too far. If we go back to the compliance blade again, we can also see the resources that are in a compliant state. So looking at the resources that are in a compliant state, we can actually dig in to this particular resource and determine and check to make sure whether that resource, whether that connected cluster resource actually has that Flux v1 configuration deployed to it. So again, if we take a look at this connected cluster, if we dig into the GitOps blade here, it's taking a minute, we see that we've deployed this cluster config Flux v1 resource to this connected cluster. So again, you can see how this is really powerful because we can provision a bunch of different clusters, we can apply a policy to them, and then an at-scale experience is basically we deploy all these configurations at once to these different clusters, and they're actively monitoring and alerting us when things fall out of a compliant state and making sure that things are consistently in a compliant state. So that's essentially what we're looking at going forward. We're looking at offering this policy very soon with the Flux v2 public preview offering. We're planning to have the public preview offering of Flux v2 very soon over the next couple months. We're currently in private preview. You can feel free to reach out to me if you're interested at all in that private preview, and we can try and get you set up with some of the docs that you might be interested in to be able to enable Flux v2 on either your connected clusters or your AKS clusters. With that, if you have any questions, again, make sure to send them over in the Slack, and Jason or I will help and reach out to you to try and answer your questions. Thank you.
Thank y'all. I'm trying to look at the channel and see if any. Okay, so here's a question. If you guys don't mind answering. I think Tamao was asking, like, she would be interested in what customers have been asking for Azure and GitOps. Like, what use cases have y'all come across?
I can go ahead and take that. Generally, it's a lot of customers that have a lot of different, Kubernetes clusters. One of the customer case studies we pulled together was Siemens Healthineers. Now they've got apps that they need to run in hospitals in lots of different locations, and so they're using GitOps and Azure to help manage that footprint. So that is based on Flux. They are writing Kubernetes applications. The customers will provide kube clusters, or they will deploy one as part of their solution, and then use Flux again to drive configurations into those environments. Also seeing a lot of interest in terms of the scenario for manufacturing, where apps need to run on site, and of course they want to make sure that those applications are kept up to date and deployed securely. SKF is another who's using a lot more of the Microsoft stack in terms of AKS and Azure Stack HCI and some of those other pieces, but GitOps is a part of that solution as well.
Awesome. I think I have another one coming through the chat. Does Azure Arc support AKS setup on developer's laptop?
AKS setup on developer's laptop. A great question. Not today. With Azure Arc enabled Kubernetes, though, the min bar is you need to be a CNCF conformant Kubernetes distro. So I, for example, do a lot of kind clusters that I'll spin up, enable them with Arc, and then I can start to bring down again, monitoring. I can bring down GitOps. I can bring down policy, Security Center, and Defender. A lot of this Azure management services.
Any use cases that have come up for machine learning and/or machine learning ops?
It's great. We actually have a first-party service that is Arc enabled. It's Azure ML and ML Studio. Again, using Arc as the bridge, you can attach Kubernetes clusters into your ML workspace and drive training and inferencing. Today, that stuff doesn't use GitOps under the covers, but again, customers who want to use GitOps techniques in terms of desired state in source repos, it's something that the teams are looking at across the board because we have done this Flux work, for example.
Very cool. Thank you guys very, very much. It was awesome hearing about this from you guys. Yeah. Oh, I guess we have another one. How compatible is this with Azure Stack Hub?
Azure Stack Hub. So Azure Arc is not baked into Azure Stack Hub. And for folks who don't know, Azure Stack Hub is a standalone pile of infrastructure that provides Azure APIs that you can deploy to your own environment. We are working on some longer term sort of convergence plans in terms of Arc to Hub. But today, Azure Stack Hub has a standalone control plane that you can drive cluster provisioning and management directly through Hub, and you don't need the Arc componentry there today.
Okay, awesome. I'll let you guys go. Thank you guys so much. All right, so next up, we are going to be hearing from Amazon Web Services. So we'll be starting with Chandler Hoisington, who is the General Manager for Kubernetes at AWS, and then we'll be moving on to Joey Wang, a software engineer also at AWS, and they're basically going to be talking about GitOps with Amazon EKS Anywhere. I'm very excited to hear you guys talk. Take it away.
Great. Okay, thanks. Yeah, thanks for having us. Really happy to be here. Let me get my screen share going. Present some slides. We don't present slides very often at Amazon, so I think this might be the third time I've ever presented slides at Amazon. So this is a special treat. So yeah, thanks again for having us. My name's Chandler. I'm the GM for EKS Anywhere at AWS, and then Joey's a software engineer on our team who will be doing the demo today. I want to start by just explaining what EKS Anywhere is. It all started a couple years ago, when we started getting requests from customers who are happy running Kubernetes workloads in EKS, and those customers said, hey, can you help me run Kubernetes workloads in my own data center? I have a lot of workloads that I can't move to EKS or to the cloud yet, and I need some help running Kubernetes there. And it was as simple as that. Amazon is pretty good about responding to customer asks, and so teams get funded and projects get funded, and out comes EKS Anywhere. And the way we approached it is we actually started with a different project. And if you've been following along, we launched EKS Distro last reInvent last December or so. And EKS Distro is essentially just the core bits and binaries and container images that we would consider that makes up like Kubernetes. It's about 15, 20 different container images, the Kube API server, etcd, et cetera, just what we would consider like the core set of images and binaries. And it's the exact same ones we run under the covers with EKS. As many of you know, EKS is in no way ever going to be a fork, but we do apply some patches. There's some security patches, some operational patches, things that are waiting to get upstreamed, things like that. And then we also version certain components slightly different. We might pull a different version of that CD down that the upstream doesn't recommend because we want some performance feature or something like that. So we wanted to publish EKS Distro to give you the exact same experience as far as the underlying bits and images goes that you get with EKS. So if you're running a platform on-prem, you can run it in EKS Distro mode by pulling those images from our builds. So that was EKS Distro. And then we built on top of that with EKS Anywhere. And EKS Anywhere is that full-fledged on-premise Kubernetes platform. And that has an installer based on Cluster API, and it has a default CNI that we ship with it. And over time, it'll have more and more components that we pull from the open source community that we would ship by default. And that's a fully supported product, supported by AWS, all the components, every open source component, every component that gets shipped is supported by AWS. It's also an open source project on GitHub, Apache 2 licensed. And yeah, that's our product. So now looking at kind of how this fits into the AWS Kubernetes, this is what this slide's about. Really, how does this fit into the AWS Kubernetes offerings? You pretty much have every checkbox now as far as managed offerings from AWS to customer managed Kubernetes offerings. So on one side of the scale, on the far right here, you would have, you could run EKS with Fargate, where you give us your container and you just deploy it onto EKS with Fargate. You could run EKS with managed node groups, where you manage the worker nodes. You could run EKS where we just manage the control plane and you bring your own worker nodes. And then if you're like, okay, well, I want to run Kubernetes in my own data center, you could run EKS on Outposts. And we're also coming out with an offering where you can run EKS on Outposts where the control plane and the worker nodes run on the Outposts, because the way EKS works today is that the control plane runs in an AWS region and just the worker nodes run on your Outposts. And then if you say, okay, I don't want Outposts, I just want to run this on my own hardware, then you can run EKS Anywhere. And if you say, okay, I don't want to use your platform, I want to use my own, Kubernetes distribution, then we say, okay, well, you could use EKS Distro under the covers there. So I think we've checked almost every box. It's a lot of boxes there, but that's kind of the scale. That's the way I think about it. My brain works, where AWS managed all the way down to customer managed and everything in between. So the use cases, someone asked use cases for Azure Arc earlier. I mean, our use cases are really built around customers who have existing investments in on-premise infrastructure, or they have reasons that they can't move to the cloud, certain workloads that they can't move to the cloud. And this is just a couple of reasons. If you really start thinking about it, there's actually a lot of reasons people are still going to run workloads on-prem. You might have a cruise ship in the middle of the Atlantic who doesn't have good bandwidth at all times, and they actually basically run floating data centers. You might have a very sensitive data center with highly secure information in it that they want to keep completely air gapped with no access to the internet at all. Somebody might want to do that. You might have an offshore oil platform or something like this that doesn't also have good connectivity. And then you might have governance reasons. You might have finance institutions. We've talked to some some foreign national countries that are basically have these requirements now that if political events got weird, they could shut off everything outside of their country and still be able to run their core workloads inside their country. So they want to have their own data centers there and be able to run their own workloads there. So there's actually dozens and dozens of reasons why people would continue to want to run workloads on premise, and we want to help them with all of those reasons. So what is EKS Anywhere exactly? As I explained earlier, it's building on EKS distro, but it's essentially a cluster installer, cluster lifecycle manager that is built, as I mentioned earlier, on top of Cluster API. We're really excited about that project. And then we bundle it with some what we would consider basic components. But then over time, we're going to add a lot more functionality to this. But we started with two really key third-party tools. One being Cilium, which is our third-party CNI that we bundle by default. And then the second thing being Flux, which is how we really recommend people interact with their cluster, not just here, but any Kubernetes cluster. We really feel like the old imperative ways of doing things where you type in a command and then hope for the best and hope that your cluster doesn't go down, or if it does go down, you remember all the commands you typed. We're trying to do away with that, and we're trying to steer people towards more of a declarative approach. Obviously, that's why you're all here, because you're probably interested in hearing about that. And Joey will demonstrate that in a second, how that works with EKS Anywhere. But over time, we'll bundle a lot of other things. And then this runs today on top of VMware vSphere, and we're adding support for Cloud Stack, which is another open source virtualization platform. And we're also adding support for bare metal. And both those things are coming early next year. And over time, we could potentially add support for other providers for Cluster API, as well as customers ask for things. It just becomes a roadmap prioritization exercise. So yeah, that's EKS Anywhere. Hope that makes sense. I'm happy to answer more questions about that after Joey's demo. And then again, we talked about the value prop. This is all about running it on your own infrastructure. We also are looking at ways to help customers with what the edge, which is a very loaded term, obviously, but infrastructure that might be a smaller footprint than a full data center. And then it's really built around helping EKS customers and on-prem. We're less focused on customers running on multiple clouds. We're really more focused on EKS customers who have on-premise use cases. And then a one-stop shop for all the support if you so choose to purchase that. The product itself is fully open source. Anyone can download it and use it today. But if you want support, that's what you pay for. Okay, so here's another look at all the components we packaged into it so far. And again, it's a V1. We have a lot more things we want to do, and we're pretty excited about our roadmap, which we'll also be making public on our GitHub roadmap shortly. So with that, I think I did my 5 minutes. With that, I will pass it over to Joey to do a demo of how this all works.
Yep, that sounds good. Okay, let me share my screen here. All right. Hey guys, I'm Joey, and I'm a software engineer from Amazon EKS Anywhere. So today, before we jump into the demo, I'd like to give you a brief overview of how EKS Anywhere integrates with Flux and how we use GitOps to manage and update a EKS Anywhere Kubernetes cluster. So at EKS Anywhere, we want to meet developers like you, where you are. There is a long list of things you should already know ahead. First, Kubernetes. Second, Git. And that's it. So we're building a command line tool that is meant to be simple and boring, to provide an easy but robust way to install Kubernetes anywhere, in VMs, on bare metal, or any other environment. As customers use Kubernetes for more of their infrastructure management needs, they often have to create and run multiple clusters across cloud providers and on-prem locations. And using kubectl offers a lot of control and immediate feedback, but it's rather hard to audit, to recover, and trace. So in recent years, AWS has come up with many infrastructure frameworks such as CloudFormation and CDK that popularize the idea of version controlled stack to manage infrastructure. This analog, in my opinion, should be carried over to the Kubernetes world, where EKS Anywhere can offer similar advantages over these ad hoc modifications made using kubectl. So for this purpose, we adopt GitOps methodology that uses Git as a single source of truth to manage pretty much everything in the cluster, which includes like the cluster config, the underlying infrastructure, and also customer applications in a declarative fashion. So people build websites or even writing books on Git. It is the most popular version control system today. It's all about who changed what and when. So managing a Kubernetes cluster should not be different. It should be natural, standard, and traceable. So here on the left side is a diagram of our cluster creation workflow. The user simply need to define a cluster spec YAML file along with some Flux configurations in that, such as repository name, username, if it's a personal account or not. And they can just run the EKS anywhere create command. After the workload cluster get created, as a post-installation step, we will bootstrap Flux and install its CRDs and components such as the source controller, the customization, Helm, and notification controller to the Flux system namespace. And we will also install our EKS Anywhere CRDs and a cluster controller that keeps the EKS Anywhere cluster status in sync with the underlying cluster API components, which we rely on for provisioning and the operation of the cluster. And finally, the cluster spec file will then be pushed into the remote Git repo we specified, along with the Flux system components. So this is how the files get laid out in the Git repo. For instance, the EKS A cluster YAML will carry the main cluster config resources, as well as the GitOps config, where it specifies the basic fields such as honors, the repo name, things like that. And in the Flux system directory, the Flux patches file allow us to bootstrap Flux with customization, where we can use our self-hosted Flux controller images in Amazon ECR. And there is a read-only Flux components file that defines the Flux CRDs, as well as the deployment for Flux controllers. Now, whenever we want to update the cluster, the only thing we'll need to do is to update this cluster spec file, then push it to the Git repo. The Flux controller will then detect the source changes in the repo, apply those changes to the EKS Anywhere custom resources in the cluster, only if the change passes the EKS A webhook validation. And our cluster controller will then start the reconciliation process, where it parses the cluster config, updates the cluster API spec, and applies it into the EKS Anywhere cluster. So we can then just have an updated cluster that matches the one we described in the Git repo. Now, I like to walk you through a demo I recorded last week. To save some time, I sped up some parts of the video, for example, during the create cluster command, which usually takes 10 to 15 minutes to provision a 3 control plane and 3 worker node cluster on vSphere. And I'm going to demonstrate the actual user experience about how we create a Flux enabled cluster on vSphere using our command line tool, and how we can manage that cluster in the GitOps way. So let me switch. So the first thing we do is to define a cluster spec file. Here we call it eksa-demo.yaml file. And for example, here, I want to create a cluster with 3 control plane node, 3 external SCD, and 1 worker node. Each one of them has a machine group ref, which in this case points to a vSphere machine config that you will see after. I also have the data center ref that includes all the vSphere data center configurations. You can see here, I can also set up my CNI. In this case, I use Cilium as my cluster networking interface. I define which Kubernetes version I want to be using, or whether I want to use a local registry or not when pulling the images. And here in the bottom, I also have the GitOps section where it points to a GitOps config resource. So next page here, specifically for vSphere data center, I provide things like server address, network, some print, etc. And for control plane, worker nodes, and SCD, I also define all the infrastructure settings such as data store, folder, CPU memory disk, and SSH key I can use later to access the nodes. And finally here, for the GitOps config, I choose Flux as my GitOps tool. And in it, I have GitHub as my Git provider. I specify my GitHub username and repo name, whether it's a personal account or organization. Notice here that the repo does not need to exist ahead. The CLI will simply create one for the user if it's not there. And there are also some optional parameters that are not listed here where user can specify things like customize Flux system namespace, which branch to use, the cluster config path, things like that. So we go ahead, save the file. And we can export the vSphere username, the password. And for Flux, we also export the GitHub personal access token. Then we go ahead and run the EKS anywhere create cluster command, and we pass in the cluster spec file we just defined. We run the command, and by the logs here, you can see we first do some pre-flight checks. We validate if the GitHub access token has a required repo permission for us and Flux to commit and push to the repo. We then validate the provider environment, check if the Flux cluster config path is valid or not. And then we create a bootstrap cluster, which is a temporary cluster we use to provision a target workload cluster. Then the cluster API controllers on this bootstrap cluster will create the actual workload cluster on vSphere, which is the actual Kubernetes cluster the end customer will be using. So after both control plane and worker nodes are in ready state, we then install Flux components on that workload cluster. We set up the Git repo, we push our cluster spec YAML there, and deploy our EKS Anywhere cluster controller. And in the end, we will just move the cluster API components from the Bootstrap cluster to the target workload cluster so that later on we can still utilize cluster API to run other operations like cluster upgrade and delete. Now the cluster command, create command succeed. Let's point the kubeconfig file to the cluster we just created. We can simply run kubectl get nodes. You can see I have 3 control plane, 1 worker nodes, all in ready state. And kubectl get machines. You will see the actual vSphere machines that are provisioned for both CD, for control plane, and for the worker nodes. And of course, you can run kubectl get pods. You see here, except the default kube system components, we also have the cluster API and provider specific components spin up here. And all the Flux controllers under the Flux namespace. And we also have the EKS Anywhere cluster controller all deployed into the workload cluster we just created. Now let's switch to the vSphere UI console here. It is pretty clear to see the actual VMs being provisioned and spinned up. You can also check the VM spec in there for network, for resource, for things like that. We can also install some resources and use EKS connector to connect this cluster to the EKS console. I'm just fast forwarding this part here. But you can see when I refresh the page, this EKS A demo cluster will show up. You can easily check all the pods that are running in each node, like the create timestamp, the container runtime, the OS images, and CPU memory capacity, whether the node condition is under memory or disk pressure or not. All these things are listed clearly here through the EKS console. And you can also see in the workload here, you will see the Flux controller listed and running with the number of replicas there. So next, I like to show you how we can manage this cluster with GitOps, like the real magic part. Specifically in this demo, I want to scale up the number of worker nodes and also change some resources back in this worker node group. So after we run the create command, the CLI will automatically clone and sync the Git repository we define in the cluster config to the local machine where we ran this command. So we just cd into the Git repo. The file structure is pretty straightforward. Under the cluster directory, we have the cluster name. In my case, it's EKS A demo. And under my cluster, we have two subdirectories, the Flux and EKS A system directory. So the Flux directory carries all the declarative config being used to deploy Flux controllers. And the EKS A directory simply has our cluster spec in it. So the only thing we need to do is we want to just vim into the EKS A spec and do some editing there. So here, I want to update the worker node count from 1 to 3 to scale it up. And scrolling down here, I also want to move these nodes to a separate folder to better distinguish them from the control plane nodes. And I also cut the memory for each node to have for the demo purpose. I save it and commit. Then push the changes to the Git repo. And that's literally it. We can now just sit back, grab a beer or tea, and let Flux and EKS A controller to do the rest of the work for us. So, but let's still go back and check what exactly is happening in the cluster behind the thing. So you will see here in Flux customization, the Flux system status changed from ready to reconciliation in progress. And if we check the customization controller log, you will see here, the cluster as well as the vSphere machine config just got configured. And it says the reconciliation finished with the latest Git commit we just made before. And if we check the EKS A cluster spec again, you will notice here the replica number for worker nodes already got updated. And also the same thing happened for the worker nodes vSphere machine config. That is because Flux controllers detect the Git repo code changes and applies it on the cluster resource immediately. Then the EKS8 cluster controller we developed reconciles the changes made in this spec and updates the underlying cluster API template, which triggers the scaling and update process. You can see the logs clearly here. So after that, we can simply run the get machines again. You can see the new worker machines are being provisioned. The cluster API is doing the scaling up and updating operation and try to provision new nodes on vSphere. And for us, we just need to wait for probably 5 minutes or something to have the new nodes to come up. And if we run the kubectl get nodes again, you will see all the 3 worker nodes are up and running. Same thing for the pods. And we can always go back and check the vSphere UI again. You'll see here, the new worker nodes are successfully running in the EKS8 demo workers node now, as what we specified in the Git repo. And same thing for the EKS console. You can see all the new nodes just created 3 minutes ago and are running in ready state. And that's all about the demo. It's pretty short and hopefully straightforward. Really, I think as a user, the only thing you will need to do again is to push your code changes to the Git repo. And for EKS Anywhere, we truly believe a good product requires minimal efforts from the user. We want our user, whether it's a Kubernetes admin or developers, to be able to interact with our product using the tools they've already been using on a daily basis. And in this case, it is Git. And really, I think thanks to Flux, we are able to provide a very smooth and simple user experience to let our users manage their EKS Anywhere cluster in a native way through a Git repository. So yeah, thanks all for listening. Again, really glad to be here today. If you have any questions, really feel free to ask us through the Slack channel or just shoot me an email at joeyuan@amazon.com. We will be really happy to hear from you. Thank you.
Thank you guys so much. That was awesome. I actually learned a lot. So I do have a question, if that's okay.
I see it in the Slack chat. It's
Okay.
does EKS require a connection to AWS? So the answer is no. We are working on like some fully air-gapped features where we can bundle up all the images and components, and if you want to like burn them on a unwritable DVD or whatever, you can do that. But in about 2 or 3 weeks, when we do our next release, we're also releasing support for private registry. So you can bring the images down and put them in your own container registry on-prem, and it doesn't require any connection to AWS. We also didn't take any hard dependencies with any AWS components. Having said that, if you want to take advantage of EKS Console, which is a feature we launched, or a new feature product, I guess, we launched in preview a couple months ago, where you can basically get a single pane of glass for all your Kubernetes clusters, then you obviously need a AWS connection to do that, obviously. But to run EKS Anywhere clusters, you don't need any connection to AWS.
And then I think another one is Flux integration supported with EKS Anywhere on developer's laptop?
Yes. So during this demo, I was using my Mac laptop. So pretty much we're building a command line. It's just a binary you can build pretty much on anywhere. You can run it on Linux machine, on Mac OS, or whatever admin machine you're using.
Awesome. I think you already answered the EKS Anywhere CRDs do they use Cluster API to provision the clusters?
Yep, that's correct.
Okay. And then personal one. Can I still use kubectl to manage my clusters, like updating the EKS Anywhere resources and expect the cluster to reconcile?
Yeah, so technically, yes, you can, but we would not recommend that. I know by default, Flux prevent drift by restoring the cluster to the desired state in the latest commit configuration every minute. And the reconciliation itself can be suspended completely, although this is not the recommended way. So if the reconciliation is enabled by default, any change made to the cluster using kubectl added or kubectl patch will be reverted. When the reconciliation is disabled, change using kubectl will remain the same until the next update to the Git repo. But the recommended way is always to only commit changes to the Git repo and let Flux do the rest. Of course, you can manually do these changes to kubectl, but the whole point of GitOps is to better manage our infrastructures to the declarative and version controlled way. If you do manual changes, you will not get the benefit of version control, PRs, and a single source of truth over your stack.
Makes sense. I think we have a question that was also +1. Can you describe the flow again for cluster API? They say first it starts on the bootstrap cluster, then it... Yeah, you got it.
Yeah, so you have a bootstrap cluster where we, with a kind cluster, we actually install the cluster API resources on that. And then we use that kind cluster to bring up your actual target cluster that you want. And then we move the resources to that target cluster and then get rid of the local kind cluster. We're in a couple of releases, or very shortly, we're also releasing support for what we would call like a management cluster, where you would still go through that flow to bring up your first cluster, but that initial target cluster you bring up could turn into like a management cluster, and then you could interact with that to bring up your actual workload clusters. But today the workload clusters are self-managed, so the CAPI resources get put on the actual workload clusters themselves, and they're self-managed. But we're working on a flow where you can actually stay on a management CAPI cluster and then use that to bring up your workload clusters and control the lifecycle of your workload clusters over time.
Awesome. And I think just a bit of love for Joey on the channel. It says, Joey, your terminal theme is awesome, which is great.
Thank you.
All right. I think that's all I saw. Thank you guys so much for taking the time to come do this talk. This was awesome.
Thank you for having us. Appreciate it.
Thank you.
I think we're going to be going to a break. So Daniel, with that music again.
Fantastic. And yeah, and thank you, Pinky, for the great moderating, and reminder to people that there are additional questions we see are coming through as people are typing. So Slack is the best place. Join us on the Weave community Slack, where people can continue to ask questions even after the talks and the speakers can answer. So that was really great. So with that, yes, I think we have a little bit of a break, and we'll enjoy DJ Desired State.
world we're living in. I'ma make mistakes, I'm only human. Someone to love me. And I know I'm looking for someone to love me. Gave a lot of my life to the public.
awesome.
Thanks, Pinky, for jumping on. Oops, I turned off my audio. Got too excited about the
the music.
I got too excited about the music and us chatting about getting our next speakers' names right. So we're both coming on because we're going to get it
We're
right.
excited about this. We both have each other.
Yes.
All right. So we're very excited about D2IQ up next. First presenter is Deepak Goel, CTO of D2IQ.
Yes, and following Deepak will be Max Jonas Werner. Get my best Werner Herzog voice, a senior software developer at D2IQ. So thank you to both of you, and Deepak, take it away.
Thank you. And though I cannot see most of you or anybody, I still believe that I'm talking to real you on the other side. And thanks for having us here from D2IQ, me and Max. We are happy to share how we are incorporating GitOps and why we are incorporating GitOps in our products. And particularly, I'm assuming that most of the folks here would have heard about Kubernetes, which is leading container orchestration platform. And even though Kubernetes has been like almost 7 years now into existence, it continues to be complex, operationally heavy when it comes to dealing with it. I mean, it is one thing to provision it for just for your dev environment. That's relatively easy. However, when you start using Kubernetes in production, it's whole a different game, because now you have to worry about security, networking, storage, upgradability, observability, and all the day two operations that you need to handle or you need to have when you are running a platform in a production. And this complexity goes a notch higher when you're dealing with hybrid, multi-cloud, and different sorts of environment, right? And then what we believe at D2IQ and what we are moving towards is GitOps is the right way to manage that operational complexity, or to keep a tap on that operational complexity, because it allows you to repeat, to automate much of your operations. The second aspect that I don't find that often talk about is Kubernetes doesn't give you sort of configuration management. There's nothing like you are on your own, how you want to keep all the configurations in order for you to be able to repeat them, which becomes important as you are managing your clusters. And Git provides, because of its nature of like version control, it allows you to not only control who can make those updates to your production environment, you can also audit that over a period of time, like what changes have happened, when did they happen, and you can correlate certain events based on those configuration changes. So it helps a great deal, not only in automation, but also in maintaining your complex environment. And then when we decided in our product that, okay, we want to support GitOps workflow, we looked around and we found Flux as the project that we want to kind of adopt. And the reason for that is because Flux is Kubernetes native. So it helps when you're building something for Kubernetes, and D2IQ has, the product is all based on Kubernetes. We have, and you will see Max talking about that in much detail. But having a project which is Kubernetes native just resolve many of the problems that you would have if something is not Kubernetes native, because now you have to map many of the constructs that project would have built in onto Kubernetes. Some examples are RBAC and things like that, right? So Flux being Kubernetes native, this becomes easier just to integrate with it and have that whole GitOps workflow in your product. So that's why we adopted Flux. And our plan is to have both cluster lifecycle management, basically having to have orchestration of your cluster through GitOps using Flux, but also application lifecycle management. And so what you would see today, what Max would be talking about is on the application lifecycle management and how we have integrated Flux into our product. So on to you, Max.
Yeah, hi everyone. Thanks for having us here. Yeah, I'll be digging quite deep into how we embrace and make use and leverage Flux. So I hope I'm not taking this too far, but
Hey Max,
yeah.
just really quickly before you continue, on your
Yes.
screen share, I'm wondering if you could stop and then just try and reshare again, because it looks like some of the toolbars are still on the screen share there.
Yeah, we had that in the rehearsal as well. I'm not sure how to get rid of these.
No problem.
Like,
Let's just try again.
all right. I hope they aren't too much in the way. I guess it's still the case.
It's fine. Let's just, yeah, we'll work with it.
Yeah, right. Just ignore it. Yeah, I hope I'm not taking this too far. So I'm digging really deep into how we use Flux. So yeah, how does Data IQ leverage Flux, especially for multi-cluster application management? So I want to give a very quick introduction into what Commander is, which is the product that we offer that provides multi-cluster application management to customers. And it's basically built on 3 pillars. So the first pillar is application and infrastructure management. So you can also provision clusters using Commander. And then on top of these clusters, deploy applications. And you also have real-time cost management. And we use KubeCost for that. So we have real insight into how much each cluster costs, how much it adds to the overall cost of all your cluster. And then we have a centralized observability component that lets you easily drill into each of the metrics that your clusters expose, like how many resources are allocated to them, are they over provisioned or under provisioned, and stuff like that. So that is Commander, and we're going to focus on application management in this talk. However, that also enables like real-time cost management. So we provision the resources for this real-time cost management or the centralized observability component using Flux as well. So it's just the same, whether it's centralized observability or any other application that you deploy on an attached cluster. And yeah, Commander works by attaching clusters to it, right? So you have a Kubernetes cluster and then you install Commander on top of it, and then you attach clusters to it, right? And we also ship a web UI that helps you like getting an overview of all your clusters and attaching them, adding them to workspaces, deploying applications onto them and stuff like that. So what did we use before we used Flux, which is actually not that that far in the past. We started using Flux like a year ago, or not even. So before that, we had a component that we call Kube add-ons, which was like an in-house component that we built, and it's basically a Helm operator. So we shipped a couple of CRDs, mainly an add-on CRD that lets you specify, like declaratively install a Helm chart, right? So you specify the chart's name, the chart's version, the repository, and the values that you want to provide to the release, and then create that resource, and then the accompanying controller would create the Helm release, or whether like shell out to Helm or use the Go library in later versions. And adding to that, Commander uses kubefed. which is still a core component that we use even when we started using Flux. So kubefed is a pretty nice tool for those who don't know it for like attaching a cluster to another cluster, right? So it's kind of an operator that comes with a set of CRDs as well. So you have like a kubefed cluster CRD that you create, and you put a kube config in its fields, or reference a secret that holds a kube config, and then kubefed takes care of attaching that cluster, and then you can create federated resources and say like, hey, I want to create this federated config map on the management cluster, and then kubefed takes care of federating it out to all the attached clusters. Right. So why did we switch to Flux then, when everything worked so well? And we were actually approached by customers who said like, hey, we have the GitOps workflow applied in our company for like certain workloads, and we would like to use Commander in the same way, like, right? So we would like to enable or disable certain applications on certain clusters the same way as we do with our in-house applications. They wanted to make use of central logging, of application toggling. They wanted to make use of a central storage, so you can have like, you have a single view onto which applications are validated and where. And they generally want to employ well-known practices like a code review before the change actually gets applied. And with the GitOps workflow, you also get a simple way to roll back changes for free. However, we didn't want to make the transition too hard for customers already using Commander 1. So we put kind of an abstraction layer on top of it and said, hey, we want to provide a smooth transition experience in the first versions of Commander. So we still provide a Kubernetes API-driven approach to application management. And you will see in a couple of minutes how that works. So what happens when I attach a cluster, or rather, how do I attach a cluster? So Commander has the concept of a workspace, which is a CRD that we ship Commander with. And it's basically reflected by namespace, by simple Kubernetes namespace. And then in that namespace, you create Commander clusters that are reflected by kubefed clusters. And then these clusters are attached to Commander. And from then, Commander is basically taking care of managing these clusters, right? And in this picture, we have 3 applications defined in a workspace. We're going to see later how that works. And these applications in that workspace are installed on each attached cluster in that workspace, right? So when you if you would attach a third cluster to that workspace, all these 3 applications would be installed automatically on that cluster. So how does the GitOps view on this look like? So as I said, you attach a cluster, and as soon as that happens, one of our controllers kicks in and creates a Git repository object. And that repository object points to a Git repository that Commander ships with, right? So when you install Commander, it will, part of the installation is spinning up a Git repository that holds all the application's definitions, and that will from there be used to manage all the applications. So every application that is managed by Commander is in that Git repository. So it creates a Git repository, and it creates a customization pointing to a certain path in that Git repository, depending on which workspace the cluster has been attached to. And that's like Git repository and customization are just pure Flux custom resources. And this is how the Git repository that Commander ships with looks like. We have services in there, and you can have different versions of these services in there. And in these services folders, you have the usual like manifests, which are mostly ham releases in our case, like or in Commander's case. And then when you create a workspace, one of our controllers kicks in and creates a folder with that workspace's name, in this case foo, and create a customization file in it, referring to all the enabled applications. In this case, the base folder just holds Helm repository definitions manifests. And in this case, we have Grafana logging and MetalLB enabled by default. So anytime you attach a cluster to the workspace foo, this cluster will get MetalLB and Grafana logging installed automatically as soon as the attachment is complete. And how does that work? How do I enable an application? As I said, we want to provide a smooth transition. So you do this by creating another custom resource, which we call app deployment. So let's say you have a workspace foo, and in it you have two app deployment resources called app1 and app2, and these are reflected as Helm releases on the attached clusters, right? And now you create app3 as an app deployment, and then the controller I talked about kicks in and basically creates another line in this customization file. And from there, Flux takes over. And this is really like very comfortable for us because we only create resources or like we commit to the Git repository, and from there don't have to worry about anything because Flux just does the rest for us. Right? So we go from only having Grafana logging and MetalLB there to having Grafana logging, MetalLB, and DEX referenced in this Kubernetes customization file. However, as we embraced Flux more and more in the process of getting Commander 2 out the door, we faced certain challenges. Three of these I'd like to lay out further. The first one is, how do we deploy the same application multiple times, given that we have the application definitions pretty statically defined in the Git repository? The second challenge is, how do we offer the ability to deploy different versions of the same application to different clusters? And the third challenge was, how do we dynamically inject values to Flux managed resources? I'm going to talk about what that really means. So the first challenge we ran into was, how do we deploy the same app multiple times? Because as I said, when you like we have the services defined, we ship the service definitions. So like resources like the Helm releases have like a static name, right? So we solved that by applying patches. So whenever you create an app deployment, actually a patch gets added to the customization that we saw before. And this is why I said it's not only adding this line, it's also adding these patches. So what it does is it patches the targeted resource, which in this case is the MetalLB Helm release. It patches the metadata's name, right? So you can have the same application, like the same service definition, and reuse it in different deployments. So in this case, let's say you have an app deployment myMetalLB and myMetalLB2 targeting the same cluster, you will have two MetalLB instances running in that cluster. One is called myMetalLB and the other one is called myMetalLB2. And this frees us from having to like copy the service definitions and keep them in sync. So we always have like a single source of truth for a single service and just patch it a little to be able to be deployed multiple times in parallel. The other challenge was deploying different versions of the same app, which is pretty simply solved by are a directory structure convention, which is like service name, service version, and then a manifest, right? So you would just reference another version. In this case, you could install Grafana 6.13.9, or you could install Grafana logging 6.14. So it's your choice. Or you can deploy both in parallel using like this approach. And this is done automatically for you, right? So you create the app deployment, and since you can't create an app deployment, two app deployments with the same name in the same workspace, you have to use different names, and then our controllers take care of patching the customizations. And then the third challenge was quite interesting, and it took us a little time to wrap our heads around this, which is, as I said, we have the service definitions statically defined in the Git repository that we ship command with. However, when you attach the cluster to a workspace, that workspace's namespace is reflected on the attached clusters. So, say you have attached the cluster to the workspace foo, and then all the resources are being installed in the namespace foo on the attached cluster. And since this namespace is dynamic, depending on how you name your workspace, we have to somehow dynamically configure the Helm releases and basically any other resources we create in the workspace. And we chose Flux's mechanism of substitutions by creating a substitution vars config map on every attached cluster in every workspace, or rather in the workspace, in the namespace on the attached cluster. And then we are referencing that config map in the post-build section of the customization. And then we can replace, or rather substitute, the variables of each Helm release. So the convention is when you create another service and you define it, the namespace has to be a variable, in this case, referencing the release namespace variable, right? And then you get dynamically injected values. And also you don't have, you don't have to copy the service definitions just to be able to install the same application in different namespaces. And one of the takeaways I would love to bring across here is that you don't need to be afraid of writing controllers that do GitOps themselves, right? I love automating things. I'm kind of a lazy person, so anytime I have to do something twice, I write a script for it. And automating things is just very comfortable. And it's also very comfortable to write controllers that actually do GitOps themselves, that commit and push to Git repository, right? There's very good libraries out there. There's libgit2, there's GoGit. Both are used by Flux as well. And you can basically write your own abstraction. However, you need to use Git around these libraries. And in the beginning for us ourselves, this was a little weird. Like, we were used to creating Kubernetes resources and interacting with the Kubernetes API. But as we got more and more into it, we got more intimate with, just doing Git operations in our controllers, which is a very cool thing. So how do we envision the future of using Flux in our product? We would like to make more use of Flux native resources to be able to provide users with an application status, right? So customizations have a nice way of specifying health checks. In a declarative way, so you just add health checks to the customization, and then the customized controller will take care of setting the customization status. And the only thing that you or rather Commander and our controllers have to do is look at this customization and see whether the application is healthy or not. So you don't have to drill into the application's details and see whether the deployment works or everything. That's done by the application definition author, right, who writes the health checks, which is really nice. And our mentality around this is upstream first. So anytime we have a challenge in front of us, we look like out to the world to see whether there's a project that already solves this problem for us, like an open source project. And then we embrace it, we use it, we make use of it. And that's the same way how we started using Flux, because it solved a lot of the problems that we had, a lot of the features that we needed. And then we basically ditched our own implementation of parts of it and embraced Flux. And that worked very well, right? And then other features are, we want to provide the ability to use multiple Git repositories, because as I said, at the moment, it's like one central Git repository. But for better isolation and to be able to let users actually use, clone and commit to the Git repository, we need isolation, because otherwise you can, you can see everything every cluster has deployed. And a feature that we really like is remote customization application. So customizations have this kubeconfig field. So we wouldn't even have to create customizations on the attached clusters anymore, but could just create customizations on a management cluster for each attached cluster and just add the attached cluster's kubeconfig there and would have everything on the attached cluster. This has pros and cons, and we're still evaluating whether we want to do that or not. Otherwise, reach out to us. I hope I didn't overwhelm you with Flux details and really digging into it. Reach out to me personally on Twitter. We hang around in the Flux channel and the CNCF Slack. And we also hang around in the SIG multi-cluster Kubernetes Slack channel. Thanks.
Thanks so much, Max. It's great. We just have like a couple minutes. We had a question first asking in Slack, is Commander open source?
No, it's not. I don't know if Deepak has a longer answer to that. I don't.
Excellent. It's a yes or no question, and you answered. Oh, Deepak.
So we are a very small group here of engineers, and when we evaluate whether we want to open source something or not, the intention is there. It's just that the bandwidth is not there, because we don't want something to open source and let it float and let's say, hey, somebody else manage it, because it's easy to just open source the code. But when we say really open source, it's a hell lot of an effort. And I know folks from here who have been involved in open source. It's hell lot of an effort. So right now it's more about the bandwidth question, not the intention. So yeah, we'll see if in future we would be able to open source it. And it's Commander by K. I know we go by K for everything. So we have 3 products: Convoy, Commander, and Captain. All are by K.
It's great. Yes, I think because of Kubernetes, the ecosystem is trying to use up every possibility of converting a letter to K.
That's right.
Thank you. And if there are any more questions, as I mentioned, we're on the Slack, so we can continue to. I see Lee posting ecosystem with a K. Yes, we'll keep working on that. And just quick shout out. I've heard from definitely in conversation with the Flux maintainers. They're very thankful for D2IQ people in the community and in the company contributing quite a bit to Flux. It's been great hearing positive things about the collaboration, and that's what's so great about the community and Lee, the ecosystem. So with that, I thank you very much, and it was a fantastic talk, and we'll continue chatting in Slack.
Thank you for having us.
Yes, thank you.
Thanks for having us.
So with that, we will come on to our next speakers from VMware, good old friends, Ben Hale, as well as Lee Kapili, who many of you probably know, was in our team before. Hi, Ben. It's been a long time. And Lee Kapili, that many of you know, who's on with us in our DX team on the Weaveworks side, and now, excitingly, has joined Ben's team and others working on the Tanzu side. So I'll go to my formal introduction. So we're really excited that they're showing GitOps with VMware Tanzu, and Ben is senior staff engineer at VMware, my old haunt. It's great seeing you. And Lee is staff developer advocate. So Ben will go first, I believe, and Lee will show the rest of the product. So thanks, both of you.
Yeah, thank you, Tamao. It's been great to see and work with you again after all these years. I'm going to go ahead and get started with the slides here. In my role, it means all slides all the time these days, sadly. So the title of the talk, GitOps with VMware Tanzu Application Platform. We are going to talk a little bit about TAP, but I'm going to try and focus a little bit more on how we use Flux in sort of a novel way. The change to sort of the GitOps toolkit kind of thinking has been really, really great for us. So my name's, as I was introduced, my name's Ben Hale. I am the technical lead for the Tanzu Application Platform. It means that I am still, an engineer at heart, and I think about things that engineers do, and especially customers, application developers who need to build on top of Kubernetes. Lee, why don't you go ahead and introduce yourself as well?
Yeah, I love being here with this community to speak. Many of you might know me. My name is Lee Kapili. I now work with Ben and the Tanzu team. I'm a developer advocate for all things Tanzu related, including the Tanzu Community Edition, freely licensed open source distro that we just released. You can experience like all of Tanzu, and yeah, we're doing cool things. Super excited to be talking a little bit about the Carvel tool set and what we're doing with Tanzu Application Platform, because we are building stuff and extending on top of Flux, and that's a really cool place to be.
Okay, so let's go ahead and get started. I'm going to talk a little bit about our product. I swear I'm not going to try and sell you on it. I'm sure I can find a salesperson who will do that if you really want it. But let's start with like sort of the base here. We sort of come to Tanzu by saying we believe that Kubernetes is good. I look at this and I see a huge amount of opportunity, a huge amount of flexibility, a huge sort of canvas for our teams or our customers to actually build great things. But I also see a lot of complexity here. Our customers see a lot of complexity here. How exactly do you select what you want to run out of here? If you're an application developer, how much of this really matters to you? And how much is sort of incidental complexity that gets exposed to you? And so that's what we see. Like, for all of the greatness that is Kubernetes, application developers, especially once you get beyond that really early adopter phase, application developers realize that they're looking at hundreds of lines of YAML, what we affectionately call internally a wall of YAML, that sort of impedes their ability to do what it is that they're there to do. I come from a long background working with enterprise customers especially, and for them, the question is like, I need to deliver a new piece of functionality for my insurance company, or a new way to evaluate car loans for my car company. What they're not there to do is make sure Kubernetes is tuned to the nth degree. That's like a real big problem for them. And really, when they come at it, the argument always is, this is impeding my ability to deliver business value for my company. So what we've started work on is the Tanzu Application Platform. We had a couple of really big beta announcements at Spring 1 and VMworld. We're looking at GA sometime in the new year for this. But the goal here is effectively to build an application-aware platform on top of Kubernetes, to say, build the platform on top of the platform. The goal is basically to take really good developer outcomes. My history is from the CF side, although I don't work on it anymore, the Cloud Foundry side. And we've always gotten from our customers the Cloud Foundry's developer experience was absolutely top-notch, basically the gold standard for what a developer wants to do with their life, while there were other problems with it. So what we want to do is create a situation where while we still get all of Kubernetes, developers focus on their specific stuff, things that only an application developer can know about their workloads. Things such as, what type of workload type is this? Is this a web workload type? Is it a batch workload type? Is it a streaming workload type? Where should someone go get my source code from? Here's a Git URL. We're going to talk a little bit more about other places you might get it. What does it mean to bind to services with service claims? Say something like, here is the database that I want. Here is exactly the database that I want. And I want to get events from a RabbitMQ, and I don't really care which one, any one that will deliver me 1,000 events, for me to connect to, something like that. Environment variables, resource limits, all of those things fall into there as well. But the key thing is, this doesn't really describe what it means to actually run my application. It describes characteristics about my application. Operators, though, we separate as a completely separate role. We realize that in many cases, especially in sort of DevOps kind of scenarios, you end up being both an application developer and an application operator. That's a good thing, I suspect, overall. But the key thing is, when you think about the problem, we want a clean separation between those three things. We don't want what it means to describe my application and to work on application code towards business outcomes to get corrupted by what does it mean for this to run really, really well on Kubernetes. We see them as different skill sets, even if some people have both of them. So sort of the spine of the Tanzu application platform, by no means the extent of the entirety of what it does, is an open source project run by VMware called Cartographer. And see here, Tamao, we managed to have a K sound without making it a K. And so we have this thing called Cartographer. And what it effectively does is it's a choreographer. It introduces this idea of something called a supply chain. And so a supply chain watches for that workload YAML that you saw a little bit earlier, and it does something with that. It says, given this workload, I have a policy, a set of templates that I know what it means to run on Kubernetes properly. So we stamp out a Flux Git repository that knows how to watch that Git repository. We stamp out something for Tecton so that we know how to run your tests. We use a project called KPack, which uses cloud native build packs, another CNCF project, to turn your source into an image. We do some VMware magic that happens after that. That's the stuff that we're going to get paid for. And then eventually we sync this into something like Kubernetes. But one of the real key things here, and this is like one of the lessons I've learned over my career, is I think this is a really good combination. I think customers can have a huge amount of success doing something like this, but not all customers will do that. We need to make it possible to meet a customer where they are, for them to say, I have a different opinion than you. Instead of Tecton, what I actually want to use is Jenkins to run my tests. I want to be able to have a way in and a way out that kicks out to a thing that I already own. Maybe you aren't, invested in the idea of build packs. You've had bad experiences in the past, or for whatever reason, you're on Docker files. Okay, cool. And sub in Conoco into this supply chain, right? Now, the key thing here is to get that kind of composability, that kind of pluggability requires something very, very special. We care about duck types, right? Duck types, for those who aren't, sort of super familiar with them, this is effectively us saying, if it looks like a duck and walks like a duck, it's a duck. It's the ability for us to say, I don't actually care whether you're using Tecton or Jenkins. What I do care about is that I hand you an input that's a piece of source code that you need to test, and that you hand me out whether or not that source code passed. I don't need to know whether you're using Docker files or build packs to build your image. What I need to do is give you some source code and expect to come out a digest of a Docker image. And that's really important for a lot of things. But most importantly for us is what happens when we want to sub out something like Git for something like Docker. And this sounds pretty crazy when you first think about it. Why would I need Docker here? That's an image. You're talking about where source code goes. But it turns out when we talk about what we call our inner loop supply chain usage, what we're actually describing here is saying, most of the time a developer is just doing this really tight loop locally on their machine, right? They're changing source code, they're testing if that source code works, changing source code, testing if it works, long before that ever goes to Git. And so the key thing here for us is say, we need to get this source code off your machine and into a blob store somewhere. What's the best way for us to do that? What's the best blob store that a developer in the Kubernetes ecosystem likely has? It's Docker. So now then the question becomes, oh, how do I change that Git repository up at the beginning? Like, I know that there was an S3 bucket that we can use. There's some Helm stuff there. It's not immediately obvious, but it turns out that Flux cares about duck types as well, because they introduced the artifact. All of the source repository types, everything that's in the source controller specifically, kicks out a status that has this artifact. And it's really great. A URL that you can download things, the revision that it was related to, a checksum to make sure that you're getting the right stuff, some information about last update times. All of them have this thing, which means we can sub out anything, because all we know is we're going to listen for changes to whatever the current artifact actually is. So we went off and did this. We did a good thing here. We went off and I'm not sure, while we use the same name, I'm reasonably sure we didn't actually fork the source controller, but we followed the same process, right? We liked this artifact thing. We built upon it both in the types that we have in our controller around image repositories, but we also built it into the way we consume things. We lean on that artifact duck type. As long as there is a status.artifact, which has a couple of things in it, we will be able to integrate with you. But we looked at this and we said, this is too important, right? Like, this is a thing that's going to be broader, much broader for other people than just for us. And we've used a lot, we've gained a lot of utility from using Flux and building on top of Flux. But what's important is we actually want to send this upstream, right? And so I'm pleased to say, as of 12 days ago, we have navigated our internal open source projects office, and we are actually contributing back to Flux. Draft PR, I know, like, it's not, I'm not claiming VMware is this huge maintainer or anything, but it's been a really great experience. We've contributed what we learned there, changed the name slightly to OCI image, taking some feedback from the Flux maintainers about what we want to change, but really having a good discussion about what it means to get this in and what it means to work in the Flux ecosystem. And so before we go any further, I want to hand it off to Lee to give you a quick demo of how exactly this works and how we see it in relation to the other source types.
Thanks, Ben. Yeah, super excited to just show this working a little bit. So here is my screen share. Again, go ahead and check out that PR. It's PR 450. On the source controller repository, not the Flux2 repo. So here I have a Kubernetes cluster. It's got a couple of components that Ben is talking about. We have this command line tool that is able to keep track of groups of resources that are installed to the cluster called cap. If you haven't played with cap before and you struggle a little bit with trying to keep things in nice, neat groups on a Kubernetes cluster, then you can see, like, okay, well, I have like groups of things. These aren't Helm charts. They're not Helm releases. They're just blobs of Kubernetes resources that are all labeled together. And there's a couple of resources that I have built with my personal platform. And I want to start leveraging pieces of this. In particular, the platform component that does image builds from application source code that we've worked on. It's pretty new. It builds on these cloud native build packs. It's called KPack, right? So KPack, you put a custom resource into the cluster. It knows that it can use a builder to do builds of an image that comes from somewhere. And so how do we get the application source code into the cluster, right? That's that kind of question that we thought, oh, well, we can use Flux's source controller for that. And so if you go and you check out Ben's PR 450 on the source controller repo, you can build it, you can deploy it like I have, and hopefully we'll be upstreaming that in the near future, or well, on whatever schedule makes sense, because we've got some interesting conversations in that thread about typing and extensibility. Really good stuff, always working with the Flux maintenance community. Now, just in this kind of examples folder where I put a bunch of all kinds of stuff, you can see this very simple OCI image resource type, right? And it starts out simple, but if you look into that API, just as you would with any Flux resource, this is a source type API. So I'm doing a kubectl explain recursively on the OCI image custom resource, right? The whole API is kind of defined here. This is totally tentative, but it's got that status sub resource and that duck type, right? If I go and I look instead at an OCI image, if I look at a bucket, this is a Flux type that has that same artifact duck type inside of the status that's useful to be consumed by other controllers. And then you can see that, Git repository also implements that, right? So, okay, we can see that I've got this Prometheus OCI image, right? I want to put this source into the cluster, have Flux reconcile it. It's just sitting out on a public registry. So it's going to be able to fetch that image for me. And we want to see that we can reconcile it and make the source available inside of the cluster. If you don't know anything about source controller, I'll kind of show you how that works. But here we're grabbing the Prometheus package from the Tanzu Community Edition repository at a particular immutable SHA, right? The thing that's nice about using a SHA instead of an image tag is that you know that the thing that you're pointing to is never going to change, right? I have this exact package coming into my cluster, and you can see why that would have some useful properties, especially for continuous delivery and more of a production setting. So I go ahead and then just kubectl apply that Prometheus OCI image. Get the normal kind of message back from the cluster. That says configured actually here. I'll be a little more honest. I guess I had that over there. We'll go ahead and delete that. All right, so if I get OCI images in the cluster across all namespaces, there's nothing there. And we apply our resource. Then we check kubectl to see, and we see that we've created that resource. It's called Prometheus, and it references this particular image. And then we see this status message from source controller that's saying, hey, I went and did that thing for you. And then you can also look at the logs. I have source controller installed in a namespace called GitOps Toolkit. And we can see that it was performing a bunch of reconciliations on that end as well. So just a little bit of observability there. And if we describe the resource, I want the OCI image, and I'm just in the default namespace. Here's our normal status messages and things like that. And then here in status artifact, which is our duck type that we want to get our information from, we see that there's this URL subfield, right? So it tells me a little bit about the revision of what thing was pulled. A little bit of extra information here is that we are resolving the container image. In this case, I gave it a SHA already. And so it's going to go find those layers and then cache them locally and pull them just once. So the same sort of storage model that we have with Git repositories and any other artifact in Flux. And we grab this URL. I'm going to open up a debug pod. So that will be, I want to create a debug pod. I'll just base it off of the Alpine image. And then we will get an interactive shell here. And I'm going to use wget to get a copy of that archive, right? So what we see here is that the source controller service in the GitOps Toolkit namespace inside of my cluster, I want to access the OCI image type that's served from that controller. And it's in the default namespace called Prometheus with this, particular tarball. And then I can I will tar list that file. And you can see that there's the contents of that container image available over HTTP inside the cluster via Flux's mechanisms. And so you can see how this would be useful for a couple of things, right? So in this particular image package being a format that's supported via the Carvel toolset, there's a bunch of Kubernetes YAML files in here. And I'm actually going to unpack those here. So tar x the SHA 250. I don't have my autocomplete here. I guess I'll just get it again. One second, sorry, my friends. Grab this URL one more time. And back into the exec here. Cool. I grabbed that at a different URL than the previous time, which is actually interesting because it's available as both the latest tag and as this shell. So that's notable. X ZVF, and then I can just type correctly. There we go. So here in this config folder, you can see that from this upstream directory, this has been nicely packaged by the Tanzu Community Edition team. If I just go and look at like what's inside of Node Exporter, there's a bunch of normal Kubernetes YAMLs. And so here's like a cluster role definition. But then you can also see, oh, there's more esoteric things in here. Like if I go into this overlays folder, you'll find things that don't exactly look like a normal Kubernetes YAML. For instance, overlaying the node exporter here, we see something that looks like it's got more source code that's inlaid into it. And if you, the Tanzu Application Platform is not prescriptive about like what tools you want to use. It's pluggable and it's extensible, but we started to build some good opinions around overlaying and programmatically building up configuration, locking images with different tools. I'll go take a look at the Carvel tool set. In this case, what you're looking at is a structured template of a YTT program. So we can put all sorts of things inside of a image package, right? Just kind of zooming out here, we were looking at this OCI image. We asked Flux to pull this OCI image into the cluster. It became available without any sort of authentication, just over a private HTTP connection inside of the GitOps toolkit namespace that we deployed the source controller to. And now we have that source code available to us with the tar stream, nothing fancy, it's just old Unix tools. And we can pipe that to any number of things. So we've got source controller pulling in all of our source code from an image, and we could use customized controller to apply some of the YAMLs from the upstream directory. Similarly, we could build a controller that grabs all of that source code and does a YTT build on the program that was inside of the overlays folder. Similarly, we could actually have our application source code in there. Say we were building a Java Spring application or a Node.js app with a bunch of JavaScript. We could have all of that inside of the OCI image, push it up, say it's a local image from our local Docker registry as part of our development flow. And we could ask KPAC to turn it into a downstream Docker image of the application that's actually built and ready to run. And so there's a lot of really cool use cases here, right? It's not just using configuration inside of a repository to configure the Kubernetes cluster, but we can also build application workloads and we can use other templating engines. So future work here for sure. But yeah, that's kind of what we wanted to demonstrate as far as the upstream work functioning. Ben, I have been so excited to see your contributions, and yeah, it's really fun to work on the technical sides of solving this continuous delivery problem, making things a little bit more extensible. But did you have anything you wanted to add as far as consuming OCI images?
No, that sounds really good. Like the next thing that I want to say though is like this turns out to be really easy. A I am continually impressed by the Flux maintainers and how that they've made something that's this sort of composable, that we, just sort of went and did this novel thing. And it's been important enough to us, like the ease of use, that we were able to do both take on something like just the Git repository, the way that we were able to sort of match up with the duck types that the source controller uses to make sure that we could build an image equivalent of that. And from our perspective, this is just the beginning of our contributions. We really, really want to become more engaged in sort of the Flux maintainer community, putting in as many upstream contributions as the team will take for us, because we see just a huge amount of opportunity and power here. So if we go back to that supply chain, like the number one thing on our list that comes after, and admittedly, we have not talked to the Flux team, we're still sort of experimenting internally to figure out what this might look like, is if we sort of take this idea of this is what our supply chain looks like, one of the things that becomes really apparent here is this is all on a single cluster effectively. You're maintaining a bunch of resources in a particular cluster, and it's less of what you might refer to as true GitOps. But we do absolutely understand that like GitOps is a big thing. It's going to be a big thing for a lot of our customers, and much of platform's thinking starts with the assumption that GitOps will be what our customers are doing. And so one of the big questions, one of the big areas we see as an opportunity here is what happens at the end of our supply chains? Right now we deploy straight to Kubernetes, but what if we wanted to deploy instead to Git, right? What happens if we want something else like Flux or another GitOps tool sitting in another cluster, looking at a Git repository for the output of what our supply chains do? And so we're starting to take a look at like the image update automation area, and like you can feel it. The parts are there. Like they're not quite what we need to do at the other end, but the foundation exists for us to start thinking about this end of it, using Flux at this end of our supply chains inside of the Tanzu Application Platform as well. So if you do have any other questions about some of the stuff that we talked about here today, I'll make sure the slides are available with the links to those particular projects. And with that, thank you from both Ben and Lee, both me and Lee. Thank you very much for listening.
Thank you so much. It's great. So we just have a few seconds here, a few minutes. There's more of a comment, but it was interesting to see someone in the Slack saying, I can see the OCI image type being potentially useful for air-gapped environments. Very cool.
Yeah, absolutely. A lot of people won't have access to various Git repositories, and replicating into an image registry, especially as you start seeing the evolution from the Docker specification to the OCI image specification. Like you realize that they're very much thinking about it as, here is a generic blob store with a nice API on top of it. And like you get a lot of interesting things from there.
Lee, did you want to share something?
Yeah, it was just, I needed to pull up the fact that you can use image package to copy recursively bundles of things that are related to each other. And so this is a potential use case where you would want an image package bundle with a bunch of all of your Kubernetes configs that you would normally apply to the cluster with GitOps. But then image package can also reference all of the software application images that are needed to actually run the application. And if you were using an OCI image as your control repository for your air-gapped cluster, then you can do an image package copy, and you can say that it is recursive, and it will copy everything, all of the application images that are related to the config from whatever registry you have access to the registry that your cluster has access to. So totally useful for that sort of use case. Check out image package and the rest of the Carvel tool set. Yeah.
Excellent. And I'm glad I learned about duck types. I've seen that in the email threads. I've been trying to figure that out. As always, quality stuff, great stuff. Thank you, Ben. Thank you, Lee. It's so great to see you, and really great seeing this. And yes, cartographer with a C, not a K. So thanks for joining us, and we will move on to our next speaker. So we're very excited that you've had these quality companies showing up for this event. Everybody has these fantastic GitOps solutions, all using Flux. And so we're really excited to have our final vendor, who's Andrew Block from Red Hat, who's joined in and really shown some interesting stuff. I want to make sure I get your title correctly, that you are the Distinguished Architect at Red Hat. And so it's been really great to meet you in person at KubeCon, and I'm really looking forward to this. So Andrew, take it away.
Thanks a lot. Let me go ahead and share my screen. Great. So once again, thanks to everyone from the Weaveworks team for inviting Red Hat, myself, to be able to showcase how we can leverage Flux on OpenShift. So let me just go full screen really fast. So my name is Andrew Block. I'm a distinguished architect from Red Hat. I've been working in the Kubernetes and container realm for quite some time, probably since the early Docker days, definitely pre-Kubernetes. I do focus on security and automation. GitOps is certainly one area in particular that I know too well. I work with customers. I'm customer facing, so I work in the trenches, hearing how organizations, large and small, work and some of their pain points, and then I try to bring them back to the open source community, because one of the key areas that I see is that the open source community tries to think big, which is great. Many organizations aren't quite there yet, so we try to meet in the middle and see how we can take the best of both worlds, from what the upstream community is trying to do to how we can employ that within traditional enterprises. I am a contributor to many open source projects, in particular recently the Helm project, as well as Project SyncStore. Now, our folks from the VMware Tanzu team just talked about the secure supply chain. That's one of the key areas that SyncStore is looking to address. I've also written a number of books out there. Learn Helm. So if you want to learn more about the Helm ecosystem, you can go ahead and read that, as well as Securing Kubernetes Secrets. It's currently currently being published. So if you're familiar with Manning Publishing, it's in MEEP status. So you can at least start taking a look at some of the work as it's coming along. And we just mentioned I was at KubeCon last week, did speak last week at GitOpsCon and KubeCon, both great events. So especially as those continue to rotate across the world, if you're around, go ahead and try to attend if you can, at least virtually or in person. So first of all, big idea is to drive innovation. Every organization is trying to unveil new opportunities. And one of the ways that I see that is by first innovating, looking for new ideas, but they also want to be able to do so in a consistent fashion, so that regardless of where they're going to be deploying, they want to make sure it's standardized across all environments. But they also want to have the automation to reduce the manual actions. How can you scale effectively if you're trying to achieve all these different goals? And that's really where a couple key themes have emerged over the past several years. And we're not going to be talking about anything groundbreaking, especially since we're here at GitOps Days. It's really looking at two areas, two ingredients for success. First is going to be containers, container orchestration. So really that atomic packaging model for delivery, so that you can ensure repeatability, so that you don't have servers that potentially are bespoke, configured one way in one environment and another way in another environment. It's how you scale effectively and be able to manage the scaling. So containers are great when they were first created. They still are great today, but that's really where Kubernetes and these container orchestrators really started to take hold, because it became a management problem. You have all these wonderful containers, but if you can't get a grasp on them, it's really difficult to be able to scale it to wherever you happen to be hosting your infrastructure, whether it be in the traditional data center or all the way out at the far edge. And then this concept of GitOps really emerged itself as a way to achieve great success using containers, having that centralized source of truth, declarative configuration, as well as a tool that can help manage your GitOps processes. Because you can always store your source code in Git, but how you apply it to your destination is really the secret sauce. And it's the tooling that is really essential for that. But on top of that, we got two areas that emerged. We have DevOps. DevOps, the ability to use GitOps and a lot of the containerized technologies to be able to increase the speed of software delivery. We're able to bring in two bespoke areas, which is your operations team and your development teams, bringing them together to really provide this holistic solution to accelerate application delivery. And it was great. It helped bring down a lot of barriers, helped get software out there faster. But especially recently, this additional trend really started to emerge. And it was this concept of DevSecOps. Because as many of you are aware, security is front and center. A lot of industries are becoming compromised by software and malicious software and risks. This concept of DevSecOps came in to take the benefits of DevOps and introduce security as a way to really provide a way that brings in your entire organization. Because a lot of times I work with customers, they go ahead and they work on the DevOps processes. It works great, but then they're ready to deploy it to production. And then security team knocks on the door and says, hey, so about that deployment, you got to go back and fix some things. That slows things down. It ends up kind of derailing the entire DevOps process. So DevSecOps really emphasizes bringing security at the forefront. So you operate securely, but also design your application securely and operate in a traditional fashion. It's one of the key topics that I talked about at GitOpsCon last week was how do we properly secure our GitOps? And that's another talk I'm happy to give. But aside from that, I at least wanted to say that security is fundamental. So when we're talking about GitOps, we need to make sure that we have proper secure operations. And really, that's where I'm going to introduce the OpenShift container platform from Red Hat. This is Red Hat's Kubernetes distribution to enable a secure operation, but also gives you a lot of additional features like self-service capabilities, automation, collaboration between multiple groups, role-based access control, multi-tenancy, as well as I mentioned, to go back again, a secure environment that really is embracing a lot of the Red Hat values of being open source so that we have great contributions to the community, but is enterprise grade, certified, validated, and trusted. And one of the benefits of GitOps is when you introduce Flux. Flux is that GitOps engine that enables you to achieve GitOps in a Kubernetes environment. And coming together with OpenShift, you really have this perfect match between the two solutions. So what can you do with Flux on OpenShift? First of all, you can go ahead and have a one-click deployment through Operator Hub for a seamless installation and deployment of Flux itself. You can also then apply many of the primitives that make for a proper and standard OpenShift deployment. You can employ appropriate policy management so that you can leverage a lot of the users, groups, and role-based access controls that are part of the OpenShift ecosystem. You can enforce those security controls so you can take advantage of a lot of the robust security controls that OpenShift provides for both platform administrators and consumers. And then finally, GitOps for all. Not only can your application teams use it, but your developers can use it. So everyone from the platform to application teams, they can all use Flux on however they need to do to serve their business purpose. So I want to take a step back and really talk about the deployment, because some of the times getting things deployed properly is a challenge. And what Flux and OpenShift allows you to do is to have a seamless deployment through this solution called Operator Hub. Well, for those of you who are unaware what an operator is, think of an operator as a method for packaging, deploying, and managing Kubernetes applications at scale in an automated way. And not only is Flux deployed as an operator and available through Operator Hub, the entire OpenShift platform is all managed via Operator. So it's all intelligent, all automated, and robust. And that's really what you get. And deployment through Operator Hub is facilitated through the Operator Lifecycle Manager in OpenShift, which allows you to take, I want to deploy Flux. It says, hey, okay, I know where Flux comes from. Let's go ahead and then shoot out all of the different components that are part of a Flux deployment, everything from a deployment, all your role-based access controls, service accounts, and everything that you need to do to have Flux running appropriately. So I talked enough. Let's go ahead and talk about how we can actually demonstrate Flux on OpenShift and kind of get into the weeds here. So first, here are some of the key themes that we want to focus on as part of this demo today. First of all, we want to talk about just the Flux deployment, getting it quickly installed with a one-click deployment to OpenShift. We then want to go ahead and perform some management and platform management through GitOps to be able to deploy some operators to help manage the platform, as well as employ some configuration and policy enforcement. Another key benefit of OpenShift and Kubernetes is the ability to perform multi-tenant enforcement. We can basically isolate individual teams from one another, so they're not aware of anyone else running on the platform. They just think of it as their own platform. And then finally, most importantly, if you have application teams on the platform, how do we go ahead and enable them to be able to be successful by having their applications be deployed? One thing I will take a aside on is policy enforcement. If you are familiar with Gatekeeper, Gatekeeper is a CNCF graduated project under the Open Policy Agent umbrella, which allows you to enforce additional policy mechanisms within OpenShift. What we're going to do here is we're going to deploy it as a cluster operator as part of our Flux configuration in GitOps. And the one policy we're going to go ahead and implement is we're going to forbid the escalation of Flux resources by end users. So we'll kind of walk through how we can employ additional policies to as we really emphasize this whole Git DevSecOps methodology. We want to make sure that some of the policies that our security team want to employ on the platform are also granted. And we're going to introduce 3 common personas. We're going to introduce our platform manager, Alice, a developer who wants to be able to develop on the platform, John, and an SRE, Frank. And each one has role-based access control and user accounts in the OpenShift platform that allows them to have their own scope of the world. So enough of that. Let's go ahead and let's get running in OpenShift. So I'm going to first go ahead and log in as my platform SRE. So I'll log in as Alice, get them logged in. Oh, my apologies. We'll go ahead and get logged into the OpenShift environment. And this is our overview page, which provides a quick overview and dashboard of OpenShift. We go over here to the left side and we want to first install Flux. We go over to Operator Hub, which shows us all the available operators that are available in our catalog. And I'm going to go search for Flux. See it's out there. And go ahead and click on Install. It says that we want to create the Flux operator or the Flux deployment inside this new namespace called Flux System. We can go ahead and click on Install. And just like that, with a one-touch deployment, we can quickly install Flux to our OpenShift project, our OpenShift environment. And it's going to take a little bit of time for it to pull down the images and start the containers. While it's doing that, let me go ahead and pull up my source code for our deployment. We first want to run a few steps. The first step we want to do is, once that comes up, we want to set up some of the configurations. The first step we want to do is we want to set up a brand new Git repository that has all of our source code. And then from that, we're going to then deploy our infrastructure components. This is going to contain all the policies that are going to be part of our environments. This is going to be everything from deploying Gatekeeper so that we can employ appropriate policies within our environments. Let's just go back over here. And just like that, Flux is currently now running inside our environment. If we go over and look at all the pods that are in our Flux system namespace, Flux is already installed, running, no command line, no nothing, one-click deployment, all from the browser. Let's go ahead and then move on to deploying our policies. We want to enforce good policy management across our environment. And our security team wants us to go in and deploy the Gatekeeper operator. Gatekeeper is itself, as I mentioned, was that project that is under the Open Policy Agent environment that allows us to enforce proper policies within the cluster. So I can go over here and just copy this. I could use the kubectl command line, but I'm going to use the web browser here. And inside here, I can go ahead and click on this big plus sign. And then from that, it will allow me to import YAML into OpenShift. As I mentioned, going to add a new Git repository, as well as use customize as a way to render resources as part of GitOps. Go ahead and click on create. And the following resources that I mentioned were created. Basically says we have our Git repository and our customization. Now I have the Flux CLI currently installed on my system. We don't necessarily need to use it, but I kind of wanted to just show it, use it, pardon me, to show what we have in our environment. So I'm going to go ahead and do Flux get all, and then specify the namespace Flux system. And you'll see it's going to pull in saying, hey, I pulled in a Git repository, and I have a number of customizations that are going to be waiting to be deployed. Customization is leveraging the customized templating engine. If you're not familiar with that, it's a way to manage configurations so you don't have to go ahead and run kubectl, apply, or create on all these different resources. You can point it at a set of directories, and it will not only process those directories, but also perform some templating. So this takes about 2 or 3 minutes for it to pull down all the resources. So we'll give it a moment for it to do that. While it's doing that, we can see and watch some of the configurations as we go along. OpenShift also provides an API Explorer, which allows you to look at all the custom resources, all the resources that are available on the platform. So I can search for customization, and I can see all the different customizations that are currently available inside this Flux namespace, every single one of these. So if I click on one of these, multi-tenant infrastructure, you can basically provide a quick little overview of the current state of this policy. It says it was successfully applied. If there were any errors, it would then show it here inside the UI. Just going back here, checking the current state of our infrastructure components. Let's see if it gets further. As you see, we're starting to get some truths. This means that it's slowly reconciling. One of the benefits of GitOps is it's going to perform this constant reconciliation loop, ensure that all the resources as we declare them are set up appropriately. Just give it another few moments while it's doing that. OpenShift does have two perspectives, one that is an administrative perspective and one that is more developer focused, which allows you to showcase and make use of developer features. So I can quickly deploy applications and other features within OpenShift. So this allows you to, as I go through my development process, I sometimes want to test some configurations and then will verify them, all the manifests that I can then put into my GitOps system. So I kind of go in, get my Kubernetes configuration set up properly, and then pivot back to rendering them and versioning them as well. Being an architect, I typically am the one that works with my teams to be able to get the configurations just right, and then templatize them in a way that they can make reusable to make them very successful. We'll then double check back, see what the current state is of our side of things, and we are all true here. It's a little hard to see, but if we we'll just make it a little smaller. It's a rendering of the tables. You'll see that every single one of these is now true, ready to go. If we go look at our project list of projects, you should see one out there for Gatekeeper, I believe. Actually, I believe it's deployed to the Flux system. If we go over to Operator Hub, pardon me, we can go ahead and see that the Gatekeeper operator was successfully installed. So that means we are appropriately employing our policies on the platform. So we guarantee that any policies that we want to employ or restrict are ready to go before we bring on any applications themselves. All right, now we want to talk about application teams. We talked about platform teams. They were successful. Alice being our platform owner, she was the one that got the OpenShift configuration going. We want to then make applications available to these two teams. So we go back to our personas. We have, once again, John, our developer, and Frank, our SRE. We want to go ahead and deploy a new namespace for John as a developer and deploy an application for him. If we go back over here to our set of YAML, we're going to go ahead and create our staging environment, which allows us to take these configurations, and it's going to stamp out a brand new namespace called apps and deploy an application and provide access for John. Let's go ahead and let's take a look at it. Let's go back to OpenShift. Go back here. We want to quickly add some YAML. We'll paste in the YAML saying that we want to reference, the staging configuration, and we'll click on Create. And I'm going to go ahead and kind of log back out and log in as John. We should have a namespace ready for him. So John. And you'll see we have this brand new namespace called apps. Going into here, click on the projects list. We'll list all, this topology view provides a quick overview of all the applications that are currently in the environment. Taking a few moments. The bandwidth obviously is a little slow on the Wi-Fi. You know how it is. And you see we have this wonderful pod info application where we can see all the different features of the deployment. We have the deployment, a set of pods, multiple pods are running, horizontal pod autoscaler, so that we can, if we get additional traffic to this application, we can easily scale up, as well as a route. A route is a OpenShift way to expose the application outside the cluster. So we can go ahead and click on it, and you'll see we have our application just like that. Quick configuration. Flux made it really easy for us to push that changes out in an automated fashion, which is great. Our staging environment, it was working perfectly. We get it as we expect we do. Now, we have our last persona. We are in our staging environment. We now want to swap back over to our production environment. We want to then use Flux to be able to deploy our production environment, as well as make use of our SRE team to make sure that our application is running successfully. So that's where Frank will come in and be our persona in the production environment. So Alice, being the platform manager, is the one who's going to help with that. So we'll log back out and log back in as Alice, and then who has the right to perform that action. So we'll go back and do Alice, and we'll go ahead and log back in. And then from that, we can have our next set of manifests. You notice this was for the staging environment. We have this on our production environment. Only difference really here is just we're pointing to a different customization path. And that customize will go ahead and stamp out for us. But once again, go click on the plus icon, which will then allow us to add resources to our OpenShift environment. And then by creating the customization, Flux is going to go ahead and create a new project namespace in OpenShift and deploy the resources. And then from that, I'm going to swap back over to since we want to emulate what Frank will see in his workspace, I will go ahead and log back out and log back in as Frank to then see what he has. So we go ahead and log out, we'll log back in as Frank, and we'll be able to see a few key things here. One, notice he only sees apps prod. He doesn't see apps, he doesn't see our regular apps, which John has access to. This really emphasizes how Flux is able to help us out employing multi-tenant environments. Now, this could be all within one cluster, like I'm showcasing here, or it can be in multiple dispersed clusters, which is easy for demonstration purposes to just focus on one cluster. So I can go in here, once again, go to the topology view, and then see that my application is currently running successfully. I can then click on the route that's created and ensure that, yep, as the SRE team, you can ensure that it's running without any issues. Great, awesome, perfect. The last thing I'm going to do is we've now verified that John has access to the development environment. We have Frank running successfully as our SRE, making sure the application is running in production. As you see here, we're getting the nice, he's happy. Our little icon here is very happy. So our application looks good. Perfect. Let's go back and log back in as our as Alice, as our platform SRE. We want to do one more thing, and we want to really showcase how DevSecOps at ART is allowing us through a deployment, through our Flux-based deployment of Gatekeeper, able to help protect our environment. So we'll go ahead and we'll log in as Alice. We're now logged back in as Alice, and what we're going to do here is showcase one of the policies that Gatekeeper set up for us. Now, for those of you that are unfamiliar with Gatekeeper, Gatekeeper allows us to use the Open Policy Agent to employ certain policies. And you do so by creating what they call constraint templates. So I go over here and go to constraint templates. I have one called Flux Multi-Tenancy. And from that, we have a set of Rego. If you're familiar with Rego, Rego is the templating language, or the rules policy language of Open Policy Agent. And what this is basically allowing us to do is this is really where the crux of things are. I'll make it a little bigger for us to see it here. Ensuring that for our customization resource, we want to enforce that the namespace of our resource always matches the target namespace. So we want to use admission control in Kubernetes to enforce that these resources are set up appropriately. So when we try to create a resource where this is violated, we want that to be rejected. And that's what we're going to showcase here. Is we're going to go ahead and try to create a resource in our apps project, but we're then going to try targeting it to a separate project, and that we want to deny via Open Policy Agent. So we'll go here I have a sample policy here, and we'll kind of walk through this policy really fast. So we'll go and try to attach it. Notice how we want to add this policy to the apps prod project, but we want to target a different project, apps my namespace. This is one that we have a policy in place that should forbid that. Open Policy Agent should get a webhook call from the Kubernetes API to showcase how, or to basically validate that that rule is being enforced or not. If we try to create that resource, notice we get an error. Basically says admission webhook. We denied the request. Customization namespace and target namespace must be the same. Since it is not the same, it fails, which is basically what our security team wanted to employ using DevSecOps principles employed by Flux through our GitOps processes as a way that we can provide for a secure environment. So thus far, we've now showcased how easy it was for us to be able to use OpenShift to deploy Flux, Flux be able to really be the powerhouse behind GitOps to enforce not only what our security team needs, but also what our development team needs, our platform team, and our SRD team all can do all successfully within the OpenShift environment. So I'm going to close you with a couple final points. First of all, if you want to learn more about the demo, we have the resource that you can go ahead and play around the demo yourself, bit.ly/GitOpsDays-Red Hat. If you want to learn more about Flux, I'm sure you already have plenty of resources out there that the Weaveworks team has passed along as part of GitOps. And also, if you want to learn more about OpenShift, there's also try.openshift.com to learn more about OpenShift. Since we have a few minutes, I do have some time for some questions, so happy to take any questions if there are any.
Oh, sorry, my camera. Yeah, we do have a question in the channel. The question was, have you tried Flux, Red Hat, ACM, and Kyverno?
I have. Kyverno, for those of you who don't know, is another policy framework similar to Open Policy, similar to Gatekeeper. It just has, once again, another templating engine, another enforcement engine. It doesn't use Open Policy Agent and Rego. It uses its own syntax that is a little more Kubernetes friendly. So if you don't want to learn the intricacies of Rego, you can certainly look into Kyverno as another one. One of the benefits of Flux is really the ability to, be that GitOps engine that allows you to, it doesn't really matter what you deploy. It can be Open Policy Agent and Gatekeeper, it could be Kyverno, and Red Hat Advanced Cluster Management is a way that you can run multiple deployments of OpenShift and Kubernetes and manage them from a centralized source.
Awesome. I think we're going, that's all the questions that's on the channel. Thank you so much, Andrew. This has been a great talk. I guess we're gonna cut to Daniel for a little music break. So a little bit more music, and then we will be back at 15.
Thanks, everyone.
much, Daniel. Awesome as ever. Next up, we are going to have Brendan Burns, CVP of Azure Control Plane, Open Source, and Cloud Native Compute at Microsoft. And he's going to be telling us about GitOps as an evolution of Kubernetes. Thank you so much, Brendan. Take it away.
Cool. Can you hear me?
Yeah, I can.
Yeah. All right, good. I always hate it when like you get in. I got into one of these when like 10 minutes in, someone in the chat was like, is he saying something? So I always like to make sure that people can hear me. All right. Thanks for having me here. I hope you've had a good day. I understand I'm the closing. The nice thing about virtual conferences is I'm not the person separating you from the reception. I guess you can do the self-reception yourself afterwards. I'm going to talk about GitOps, and the long title of it wouldn't fit on my slide. So let's say GitOps and Kubernetes, but really talking about, I think, how GitOps is an evolution of what we were trying to achieve with Kubernetes. So I can get my slides to advance. All right, this Kubernetes thing, like, what is it? Could somebody tell? No, I'm kidding about that. But I did kind of want to go through actually what our goals were and our motivations were for designing Kubernetes, and how I think that provides a framework for what we think of when we think of the workflows that GitOps is doing. I think first and foremost, what we were thinking about when we were developing this system was the idea that we needed to both make it easy and make it safe at the same time, right? There's too much work involved in building and deploying applications, especially when you want to deploy reliable applications around the world. There's too much work involved in a developer, too many, especially back then, too many things that you needed to get right. This was one of our main motivations, I think, was that someone could didn't have to shrink away from the idea of deploying an application out into the cloud or out in a physical environment, and that hopefully nobody needed these sorts of life preservers in order to successfully manage their applications. That's a major and important part of what Kubernetes is all about, I think, hopefully. Another thing that we were thinking a lot about was POSIX for the cloud. I think it's kind of maybe easy in this time and age of the cloud native ecosystem to think like, oh yeah, applications are portable and it's easy to move, easy-ish maybe, to move an application between clouds. But honestly, especially at the time, it just wasn't, right? And the idea of like moving things from on-prem to in the cloud, or moving things from a cloud to another cloud, not an easy thing to do. You really got embedded into a particular cloud. And a major thought that we were thinking about is how do we up-level that? Can't have an ecosystem, can't have a community if you don't have a shared piece of infrastructure for everybody to build on top of. And that leads us, I think, to this idea of an open ecosystem, right? I think that it was a critical aspect of everything that we did. And I think you're seeing this reflected in the people who you've seen come and talk in the conference so far today. The fact that we can all get together around this piece of technology, the open ecosystem is a core component of what we were thinking about when we thought about developing Kubernetes. So then, given if those are the sort of the foundational tenets of what we were trying to achieve when we developed Kubernetes, I think, obviously if we're at this conference and I'm talking about GitOps as the evolution of Kubernetes, what in the world does GitOps have to do with it, right? And I think this is the most interesting part of the framing, because to be honest, GitOps is not something that was on our mind when we were developing this framework. This is, one of those things that happens when you put something out there and a bunch of people find it useful and a bunch of people start thinking about the way that they've been doing things and how can the way that they've been doing things intersect with this, community and technology that you're developing. And so it's fascinating to simultaneously say, hey, there was no way that we anticipated this idea coming forward, but then also seeing the ways in which it relates to what we were talking about, and how it relates back, and how people were inspired, I hope, by the things that we were talking about to solve a problem. And I think that the thing that we were talking about most, right, of all of the goals, that we were talking about for Kubernetes to achieve, the thing that we were thinking about the most at the time was to declarative all the things, right? And this, at the end of the day, was the most important thing that we could achieve, right? And I think we have actually gotten a really long way down this particular road. I gave a talk shortly before we released Kubernetes out into the world in the January, I think, of 2013. And it was effectively about declarative configuration and how incredibly important it was for people to do declarative configuration. And it was, honestly, I got a bunch of people coming up after the talk and saying, well, but what about my bash script? And what about my, PowerShell? And it's amazing to think, fast forward, 8+ years, how this declarative, all the things, has really transformed the way that we think about building and operating our software, and for the better, frankly, right? This has really been an important force for sanitizing the things that we do. This really intersects with GitOps, I think, when we start with just the Git part of GitOps, right? Git, you wouldn't necessarily think of Git as being a declaration, but it actually is, right? When you think about Git, it's a declarative history of changes, right? Every single, commit that you merge into that Git repository, it's a declaration of, it's a patch, really. It's a declaration of change from state A to change from state B. It's effectively this declarative record of all of the different, and it's kind of amazing, right? In some ways, this is what makes Git different than any other source control system that had come before, where it is this log of all of the different changes. And so I really think that in the declarative and making everything declarative, this idea that all of your configuration should be in Git is a natural byproduct of a desire to go declarative in everything else. Because while I think we really succeeded when we talked about making, people think about doing things declaratively, when we made people think about configuration files, and when we made people think about, a data record of what you were doing, the number of people, myself included, who even today are doing like, yes, I am declarative, kube control create -f some URL, is huge, right? And though we have perhaps eliminated the snowflakes that are on our servers, we are creating clusters all the time that are snowflakes. And again, like, I'm not here to cast stones. I've got a little Kubernetes cluster right here underneath this desk in my home, and I don't think that I could recreate it if I, yanked all the hard drives, put in fresh hard drives, and said, recreate my cluster. I don't think I could. I mean, I could eventually recreate it, but it's going to take time. There's a whole bunch of stuff, from monitoring software that I deployed once that I haven't upgraded in forever, to applications that I built and, catted a very simple deployment to deploy out into the cluster and have never touched again. There is all kinds of things running on this cluster declaratively, for which I have no declarative record of how it got there, right? And I think that in Git, we have exactly that declarative record of when did it get created, when was it modified, and with GitOps, connecting the ops part to the Git, we also know that it is reflected out into the cluster, right? And so not only is it the case that we have this declarative record of all of the changes that we've made to our configurations, but we have also the knowledge that it is the way that this thing got installed. And so therefore, if I was properly using GitOps on the home cluster, I'm using some of it, by the way. I'm using a lot of the Azure Arc stuff that hopefully you saw earlier. But sadly, there's some stuff that predates that I'm not as clean about. I could actually rip all the hard drives out of my cluster, put them back in, re-image Kubernetes. It would sync up with GitOps and Azure Arc, cluster be reinitialized, and I'd be back up and running, right? And that's a huge step forward in terms of providing exactly the same benefits of declarative infrastructure that we talk about a lot when we talk about YAML, but we don't actually necessarily always follow when we actually take those YAMLs and throw them onto the cluster. But there's a lot more in the Git that ties into some of the things that I talked about earlier as well, around making this a safer environment for people. And specifically, Git has things like code review. Right, so not only do we have this declarative record of all the changes, but we also have multiple people looking at those changes, So all of those principles that we've developed around software development, around having code review, around knowing, that multiple sets of eyes have sanity checked a particular change that we push out into our cluster, we have them here. It's very hard if you're kube control apply-effing on the command line. It's very hard to have somebody looking over your shoulder and saying, yep, that's a good change that we have going in there. Right. And so again, the movement to GitOps enables not just the declarative record of things, but the make it easy, make it safe parts of Kubernetes, where all of the workflows that we thought about in software engineering come to apply to our infrastructure as well. And when we're thinking about the ways in which we develop software, it's also important to realize that there's also this movement around shift left. And again, a shift to GitOps isn't actually just a shift to, it's not just a shift to, having a declarative record of all of your changes. It's not just a shift to having multiple people looking at those changes. It's actually a shift to having tests for your configurations, right? What is a Git repo except for a place where you can set pre-submit tests, where you can have post-submit tests, right? These are places where you can put in sanity checking. You can put in all sorts of introspection and understanding of what exactly your change is going to do, and be certain that when you make those changes, well, hopefully certain, or as certain as your tests can get you to be certain that when you make those changes, it's going to be safe, right? And again, there's nothing in that kube control-f workflow that, or even to be honest, Helm Create, or any of your other favorite tools for doing these things, there's nothing in those workflows that enable you to have that kind of testing inserted, right? And so in getting everything into a Git repository and ensuring that, the only way that configurations flow into your cluster is through something like Flux, and the workflows involved in Flux, that's the way that we can actually shift left, not just for our code that we're writing, but shift left for the things that we're deploying as well. And again, this ties in as well to the notion that we're really supposed to be making it easier for developers to do the right thing. And then I think that the final piece of this that is so amazing that ties into what we were trying to do with Kubernetes ties back to that POSIX for the cloud, right? Because we were in designing this POSIX for the cloud and this unified API for everywhere. Yes, we were thinking about how do we build ecosystems and how do we build communities, but we were also thinking the poor developer who has to push their code into all of these different environments is faced with an incredible challenge today. If we can define a higher level layer, they can stand a chance of writing applications that can go anywhere. But what we didn't talk about and what we didn't necessarily have a solution for was, how do you actually push that code everywhere? How do you actually ensure that every single cluster around the world, Azure has more than 50 regions of managed Kubernetes that people can create clusters for so that they have low latency to their users if they're a gaming company or a retail company, places where latency is critically important. 57 clusters of Kubernetes out there that are running. How do I ensure that they're all running the same version of my code? How do I ensure that they're all running the same version of policy? And how can I do that at scale without sort of having 57 directories or manually going through and checking every single cluster? And the answer in many cases for many people is this GitOps workflow, right? Because I can point every cluster at a specific Git repo and know that when I make a change, that change gets rolled out around the world. And so if the Kubernetes API is this POSIX for the cloud that allows your applications to run everywhere, a workflow like GitOps is an opportunity for you to, at scale, manage what those applications look like when they run everywhere. And I think there's huge complements in our goals of ensuring that, the declarative world is the world that you see, and the world that you see is the world that stretches everywhere around the globe. The last thing that I wanted to highlight before we end this conference is the most proud part that I bring personally from the Kubernetes experience was this community that we developed. I think there were a lot of orchestrators. People sometimes sort of forget how many orchestrators there were at the time in 2013. Maybe they weren't paying attention, or maybe they, just have forgotten. There's a lot of orchestrators out there. And while I really like Kubernetes, any one of them could have provided the solutions that Kubernetes did. And for a while there, it was a little bit of a competitive marketplace. But I think the thing that really, truly made a difference for all of us was the community that we built. And I think when I look at the Flux community, when I look at the partnerships that we at Microsoft have built with Weaveworks, when I look at all of the different people who've come here to speak, to the ways that we've contributed code into, projects that we started like Gatekeeper, projects that we can join into like Flux, projects that have been existing for a long time like Kubernetes, the shared community that hopefully you all feel and that we are experiencing today is really something that I think is common across all of these projects, and a great representation of the value of open source in everything that we do. And so I think in all of these ways, from enabling even more evolution towards declaring all the things, in enabling people to do things safely and securely, in enabling people to reach the world from a single Git repository and a single container image, and finally to come together as a single community around these ideas. I really do think that GitOps represents a lot of what we were trying to achieve in the development of Kubernetes, and frankly, a lot of what we have all achieved together. So thank you so much for listening, and thanks for coming to the conference and to Weaveworks for the opportunity to speak. And as always, I'm up on Twitter or anywhere else to hear your ideas. Thanks.
Fantastic. Really, really appreciate that. That's such a great way to end this event. And so now we're going to quickly do a group photo. So as people are joining our speakers, we're getting them promoted. Whoever was able to hang out, it's very late for others. We'll do a group photo. And as we're waiting for people to come on and turn their cameras on, Pinky, thank you for co-hosting. Brendan, thanks for closing out this wonderful day. Again, looking back to the beginning of this event, right? It started with an open source project that was trying to solve really, really specific needs at the time. And it was great to be part of this evolution and see that other people had similar needs going into the CNCF, Flux almost in graduation. And all of you, thank you so much for sharing your solutions today that I just think shows the maturity of a project that we hope to see in the next iterations, right? We're so excited to be part of the Kubernetes community. We're so excited to have so many of you showcasing where we think GitOps will go. And I just can't wait till the next year, what this event might be. So we're going to take a group photos, or I think Stacy's just capturing this and we'll do a group photo. So wave and thank you. Thanks so much. Oh, we don't see Lee's face. We can't go without Lee and Scott and a few others. There's Lee. Hey, especially because Lee's on the road. We don't know where Lee might be. Thank you again. And with that, I think we'll just do a little wrap up with, again, DJ Desired State. And thank you, all of you, for joining us. If you have any questions, you have any follow-up, when you registered, we had a couple of boxes that people could check. So if you had a specific vendor that you wanted information from, we'll be happy to pass that question along. So thanks again. And Stacy, especially, let's give a great thanks to Stacy, who's helped put this event together. Stacy makes it look all easy. With that, Daniel, take it away.
Thanks, everybody.
Thank you. Thanks, Pinky. Bye.
Thank you for having me, by the way. I just want to say, thank you for having me. It was fun. This is fun.
Thanks for being here, Pinky. That's great.
Stacy, be funny. It's just you dancing by yourself for half an hour.
Lee and Steven will keep company. I know. Oh, nice.
That's why there's a little good in everybody. Even if a person looks all bad, you know that there's at least a little bit of good in him. God is somebody who rules the world. He's sort of like a spirit, I guess, up in outer space.
Thank you, Daniel. That was amazing. I never want the day or the night for you, the day to end with your music. Much appreciated. Have a wonderful night. Hey, there's Tamao back.
Hello there.
I'll stop the recording now.
Thanks, everybody.
Thanks, everyone.
See ya.
Everybody have a great day. Have a great night. We'll see you next time.